Hello everyone. Am I audible and visible properly to everyone? Yes. So I welcome you all to the Vedantu Karnataka. I am your master teacher Rithika Ma'am. So today's topic is about the co-ordination compounds. It's about the KCET chapter. Okay. KCET du ಇವತ್ತು full second PUC ಇದೆಲ್ಲ ನಾವು ಫೋಕಸ್ ಮಾಡೋದು KCET ಇದು ಫಸ್ಟ್ PUC ಇದು ಯಾವ ಇಂಪಾರ್ಟೆನ್ಸ್ ಅದಾವಲ್ಲ ಅದರದೆಲ್ಲ ನಾನು ನೀಟ್ ಕ್ಲಾಸಸ್ ಆಲ್ರೆಡಿ ವೇದಾಂತು ಕರ್ನಾಟಕದಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೇವೆ. So you can see we have started with the biology, physics and all the classes. Make sure to go and subscribe to the channel first and hit the like button also, so that you'll get a more lectures like that to prepare for your NEET and the KCET. Clear? So just confirm me once, am I audible and visible properly to everyone? Let me check once. Whether it has started or no. Yes. Once again guys. Am I audible and yes, it's correct. Okay, little bit today different studio, so it's just like I need to cross check everything so that it's perfectly going on. Okay, yes. ಓಕೆ ಯಪ್ಪ SST ಆಯಿತು ಎಲ್ಲ ಆಯಿತು, ಈಗ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದು ನೋಡಿ ಆಯಿತಾ. ಸೊ ನಾನು ಫಸ್ಟ್ ಏನು ಕೊಡ್ತೇನೆ ನಿಮಗೆ, ಯಾವ ಥರ ಕ್ವಶನ್ಸು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ನಲ್ಲಿ ಕೇಳ್ತಾರೆ. ನಾನು ಯಾವಾಗ ಟಾಪಿಕ್ ಕಲ್ಸ್ಕೊಂತ ಹೋಗ್ತಿರ್ತೇನಲ್ಲ ಆ ಟಾಪಿಕ್ ಕಲ್ಸ್ಕೊಂತಾನೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಹಾಕ್ತಿರ್ತೇನೆ. ಓಕೆ, ಸೊ ಆ ಇಂಪಾರ್ಟೆಂಟ್ ಏನು ಹಾಕ್ತಿರ್ತೇನಲ್ಲ ಅದರ ಪ್ರಕಾರ ನೀವು ತಿಳ್ಕೋಬೇಕು ವೆದರ್ ಇಟ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆರ್ ನೋ. ಓಕೆ, ಮತ್ತೆ KCET ಪರ್ಸ್ಪೆಕ್ಟಿವ್ ವೈಸನ್ನೇ ಹೇಳಿರ್ತೇನೆ ನಿಮಗೆ. PU ಬೋರ್ಡ್ನಲ್ಲಿ ಇನ್ ಕೇಸ್ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಶಾರ್ಟ್ ಇದ್ರೆ ಅದು ನಿಮಗೆ ಮೆನ್ಷನ್ ಮಾಡ್ತಾನೆ ಆಯ್ತಾ. ಸೊ ಇದೆಲ್ಲ ನೋಡ್ಕೊಂತಾನೆ ಹೋಗೋಣ ಫಸ್ಟ್, ಬಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೋರ್ ಫೋಕಸ್ ಆನ್ ದ KCET ಇಟ್ ಸೆಲ್ಫ್. ಕ್ಲಿಯರ್? ಸೊ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬಹುದು ಇದರಿಂದ? ಜಸ್ಟ್ 1 ಸೆಕೆಂಡ್. ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬಹುದಪ್ಪ ಅಂದ್ರೆ 3 to 4 marks, or else I can tell you like 3 to 4 questions will be asked from this chapter for the KCET. ಆಯ್ತಾ, KCETಗೆ ಆಲ್ಮೋಸ್ಟ್ 3 to 4 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳ್ತಾರೆ KCETಗೆ ಆಯ್ತಾ. ಸೊ ಯಾವ ತರ, ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ 2 ಕ್ವಶನ್ ಅಂತೂ ಫಿಕ್ಸ್ಡ್, ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಂದಾನೆ ಕೇಳ್ತಾರೆ, ಫಿಕ್ಸ್ ಅದು. ಜಸ್ಟ್ ಲಿಟಲ್ ಬಿಟ್ ಆಫ್ ಚೇಂಜಸ್ ವಿಲ್ ಬಿ ದೇರ್. ಓಕೆ, ಹಾಯ್ ಆಸಿನ್, ಹಾಯ್. So little bit changes will be there, leaving that remaining things everything will be same itself. Clear? Yes. Ma'am, MBBS is already saturated. Why we need to study NEET? What is the meaning of why we need to study? We need to study, no? Yes. So that today's class is not for the NEET. We are going to do completely for the KCET. Okay. So coordination compounds, so actually it's important in the prospective wise for the PU board also, because PU board nalli needu one questions ide, one concept inda short agi bidutte avu be concepts aita. So yes, let's start with the class then. So first introduction ನೋಡ್ಕೊಳ್ಳೋಣ. ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ ಅಂದ್ರೆ ಏನು, ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಅದ್ರ ಮೇಲಿಂದ ಬೀಳುತ್ತೆ ಅನ್ನೋದು ಅದನ್ನು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ತಿಳ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ. ಸೊ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ದೆನ್. Yes, did you mark your attendance? Who is watching the video? Did you people mark your attendance? Hi, good evening Kirtana, long back not seen you. Yes, let's start the chapter then. So addition compounds, we are going to learn about the addition compounds and the subtractive compounds. 1 second, let me find the, okay, let's start with the addition compounds first. Yes, whenever the two or more, then the two simple salts are being allowed to chemically combine in a mixed ratio, then the addition compound is being formed. How? Whenever there is a addition of two or more than simple salts. Simple salts andre NaCl, ಇವೆಲ್ಲ simple salts ಏನಿದೆ ಅಲ್ಲ, simple salts ಅನ್ನ completely mix ಮಾಡಿದ ತಕ್ಷಣ, okay, when this both will be mixed, are allowed chemically to combine to in the form of a mix ratio, okay, in the form of a ratio, chemically they are allowed to mix together, okay, chemically allowed to mix together in a form of a ratio, then addition compound is being formed. Addition compound is being formed. Simple way ಹೇಳ. ಈಗ ನೀವು ಹಾಲು ಮತ್ತು ಬೋರ್ಮಿಟಾ ಕುಡಿತಿರ್ತಾರ, ಆಯ್ತಾ, ಹಾಲು ಮತ್ತೆ ಬೋರ್ಮಿಟಾ ಕುಡಿಯೋಕ್ ಮುಂದೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಿಮಗೆ ಸಡನ್ಲಿ ಅನ್ಸುತ್ತೆ ಏನೋ ಒಂದು ಎಡಿಷನ್ ಬೇಕಿದೆ ನಮ್ಗೆ. ಅದರಲ್ಲಿ ಏನ್ ಎಡಿಷನ್ ಅದು? ಫಾಸ್ಟ್ ಹೇಳಿ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ. ಏನ್ ಎಡಿಷನ್ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಶುಗರ್ ಬೇಕಾಗುತ್ತೆ, ರೈಟ್? ಸೊ ಸ್ವಲ್ಪ ನೀವು ಶುಗರ್ ಅನ್ನು ಅದರಲ್ಲಿ ಹಾಕ್ತೀರಾ, ಸೊ ದಟ್ ದ ಟೇಸ್ಟ್ ವಿಲ್ ಎನ್ಹಾನ್ಸ್ ಲಿಟಲ್ ಬಿಟ್ ಮೋರ್ ಕಂಪೇರ್ ಟು ದ ಓನ್ಲಿ ಮಿಲ್ಕ್ ಮತ್ತೆ ಹಾರ್ಲಿಕ್ಸ್ ಅಲ್ಲಾದ್ರೆ ಬೋರ್ಮಿಟಾ ಏನಾದ್ರು ಒಂದು, ಓಕೆ. ಸೊ ಅದನ್ನ ಮಾಡೋಕ್ ಮುಂದೆ ಸ್ವಲ್ಪ ಶುಗರ್ ಹಾಕ್ತಾರಲ್ಲ, ಎಡಿಷನ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಆಫ್ ದ ಶುಗರ್. ಸೊ ಅದೇ ತರ ಈಗ ಎರಡು ಕೆಮಿಕಲ್ಸ್ ಇದೆ, ಟೂ ಆರ್ ಮೋರ್ ದೆನ್ ದ ಸಿಂಪಲ್ ಸಾಲ್ಟ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, ಅವು ಕೆಮಿಕಲಿ ಕಂಬೈನ್ ಆಗುತ್ತೆ. ಕೆಮಿಕಲಿ ಕಂಬೈನ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಬಟ್ ಇನ್ ದ ಫಿಕ್ಸ್ ರೇಷಿಯೋ. ಇನ್ ದ ಫಿಕ್ಸ್ ರೇಷಿಯೋ ಫಿಕ್ಸ್ ಇರಬೇಕು. ಇನ್ನ ಈಗ ಹಾಲಿನಲ್ಲಿ ಬೋರ್ಮಿಟಾ ಅಂತೂ ಒಂದು ಪ್ಯಾಕೆಟ್ ಹಾಕಿದೆ, 5 ರೂಪಾಯಿ ಬೋರ್ಮಿಟಾ ಹಾಕಿದ. ಸೊ 5 ಬೋರ್ಮಿಟಾ ಹಾಕಿದ ತಕ್ಷಣ ನಮಗೆ ಆಮೇಲೆ ಏನ್ ಅನ್ಸುತ್ತಂದ್ರೆ, ಬೋರ್ಮಿಟಾ ಹಾಕಿದ್ಮೇಲೆ ನಮಗೆ ಟೇಸ್ಟ್ ಹತ್ತತಿರಲಿಲ್ಲಪ್ಪ, ಓಕೆ. ಅದನ್ನು 1 kg ಶುಗರ್ ಹಾಕ್ಲಿಕ್ಕೆ ಬರಲ್ಲ, ಅದರಲ್ಲಿ ನನಗೆ ಎಷ್ಟು ಬೇಕು ಅಷ್ಟೇ ಹಾಕಬಹುದು ನಾವು, ರೈಟ್? ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಹೋಲ್ ಶುಗರ್ 1 kg ಶುಗರ್ ಅನ್ನೇ ಹಾಕ್ತೇನೆ ನಾನು, ಆಮೇಲೆ ಬೋರ್ಮಿಟಾ ಕುಡಿತೇನೆ ಅಂದ್ರೆ ಆಗಲ್ಲ, ರೈಟ್? ಹ್ಯಾಸ್ ಓಕೆ, PU marks will not help in future, no, it will help ಅಪ್ಪ. ಇನ್ ಕೇಸ್ ಇನ್ ಬೇರೆ ಯಾವ್ದಾದ್ರು ನೀವು ತಗೋತಿದ್ರಿ, ಓಕೆ, MBBS ಬಿಡ್ರಪ್ಪ, ನಿಮ್ಗೆ ಆಗಲಿಲ್ಲ ಒಂದು 2-3 ವರ್ಷ ಆದ ತಕ್ಷಣ ಬೇರೆ ಎಲ್ಲೆಲ್ಲೋ ಹೋಗೋದಿದೆ ನಿಮಗೆ, BMS ಅವಕ್ಕೆಲ್ಲ ಅದಕ್ಕೆ ಯೂಸ್ಫುಲ್ ಆಗುತ್ತೆ. ಡೋಂಟ್ ಥಿಂಕ್ ಲೈಕ್ ದಟ್, ಓಕೆ. Yes, so let's start. Then the first, on the basis of the behavior in the aqueous solution, they are of the following of the two types. So first type is what? Double salts. So double salts means what? That you should completely understand. ಇವೆಲ್ಲ ಏನ್ ಕಲಿಸಿದೆನಲ್ಲ ಇವೆಲ್ಲ ಬೇಸಿಕ್ಸ್ ನಿಮಗೆ, ಓಕೆ. ಈ ಬೇಸಿಕ್ಸ್ ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಮುಂದೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರುತ್ತಲ್ಲ ಅವು ಈಸಿ ಆಗುತ್ತೆ ನಿಮಗೆ, ಆಯ್ತಾ? ಸೊ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಅಂದ್ರೆ ಏನು? ಅಡಿಷನ್ ಕಂಪೌಂಡ್ ಇನ್ ವಿಚ್ ದ ಸಿಂಪಲ್ ಸಾಲ್ಟ್ಸ್ ಡೋಂಟ್ ಲೂಸ್ ದೇರ್ ಐಡೆಂಟಿಟಿ. ಸಿಂಪಲ್ ಸಾಲ್ಟ್ಸ್ ವಿಲ್ ನಾಟ್ ಲೂಸ್ ದೇರ್ ಐಡೆಂಟಿಟಿ, ಓಕೆ. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ದ ಅಡಿಷನ್ ಕಂಪೌಂಡ್ಸ್. ಅಡಿಷನ್ ಕಂಪೌಂಡ್ಸ್ ಡೆಫಿನೇಷನ್ ನಿಮಗೆ ಗೊತ್ತಾಯ್ತು, ರೈಟ್? ಸೊ ಇದೇನ್ ಅಡಿಷನಲ್ ಕಂಪೌಂಡ್ಸ್ ಇದೆ ಅಲ್ಲ, ಇನ್ ವಿಚ್ ದ ಸಿಂಪಲ್ ಸಾಲ್ಟ್ಸ್ ವಿಲ್ ನಾಟ್ ಲೂಸ್ ದೇರ್ ಐಡೆಂಟಿಟಿ. ಅಂದ್ರೆ ಏನು? ಅವ್ರದ್ದು ಎನರ್ಜಿ ಅದರಲ್ಲಿ ಲೂಸ್ ಆಗಲ್ಲ. ಸ್ವಲ್ಪ ಮಂದಿದ ಎನರ್ಜಿ ಲೂಸ್ ಆಗುತ್ತೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ಏನಾದ್ರು ಒಂದು ಕುಕ್ ಮಾಡ್ತಿರ್ತೀರಾ, ನಾವು ವಾಟ್ ಎವರ್ ಯು ಆರ್ ಆಡಿಂಗ್ ಇನ್ ದಟ್, ಓಕೆ. ಸಮ್ ಟೈಮ್ಸ್ ಯು ಟೇಕ್ ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ಏನಾದ್ರು ಫುಲ್ ಪ್ರಿಪರೇಷನ್ ಎಲ್ಲ ಆಗಿರುತ್ತೆ, ಅಲ್ಲ ಹಾಕ್ತಾರೆ, ಅದು ಶುಂಠಿ ಏನಿರುತ್ತಲ್ಲ ಆ ಶುಂಠಿ ಚೆನ್ನಾಗಿ ಸ್ಟ್ರಾಂಗ್ ಇರಲ್ಲ, ಅದನ್ನ ಹಾಕಿದ್ರೂ ಏನು ಉಪಯೋಗ ಆಗಲ್ಲ. ಇಟ್ ವಿಲ್ ನಾಟ್ ರಿಫ್ಲೆಕ್ಟ್ ಯು ಓನ್ಲಿ, ಓಕೆ. ಆ ತರ ತಿಳ್ಕೊಬಹುದು ನೀವು ಎಕ್ಸಾಂಪಲ್, ಓಕೆ. ಸೊ ದಟ್ ಡೋಂಟ್ ಲೂಸ್ ದರ್ ಐಡೆಂಟಿಟಿ ಅಂಡ್ ಇಟ್ಸ್ aqueous solution give the test of its all constituent ions, and the aqueous solution will give its all constituents of the ion, okay. Hi Gururaj. So then double salts lose their identity in the aqueous solution. So whatever the double salts are present, avella double salts identity lose ಮಾಡುತ್ತೆ ಎದರಲ್ಲಿ? aqueous solution ನಲ್ಲಿ. But they will not lose their identity in the addition compound. Clear? Simple salts addition compound ನಲ್ಲಿ ಅವ್ರ identity ಅನ್ನ lose ಮಾಡ್ಕೊಳ್ಳಲ್ಲ. Done? Let's move to the next part. Double salts ತಿಳಿತಾ? Next comes same example in this way only. KCl plus MgCl2 when it is getting reacted with 6H2, okay. ಯಾವಾಗ H2 6H2O ಜೊತೆ ಏನ್ ರಿಯಾಕ್ಟ್ ಮಾಡುತ್ತಲ್ಲ ಅವಾಗ KCl and MgCl2 6H2O in the presence of aqueous solution, K plus and Mg plus 2 plus here the chloride, that is 3Cl which is there, that is going to be in the presence of AgNO3 solution. AgCl white PPT is being formed, okay. AgCl white PPT is being formed. ಯಾವ ತರ PPT ಇದಕ್ಕೆ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ? Has I told you that the identity ಏನು ಲೂಸ್ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ, ಅದಕ್ಕೆ ಇದು ಐಡೆಂಟಿಟಿ ಲೂಸ್ ಮಾಡ್ಕೋತಿಲ್ಲ. ಕ್ಲಿಯರಾ? Next, number of ions will be how much? 5 itself. Clear? So ಅದಕ್ಕೆ ಇರೋದು means whatever the double salts is there, this is going to be the double salt here, and it will not lose its simple salts in the double salts because it is an addition compound. Okay, addition compounds ಅಲ್ಲಿ ಅದರದ್ದು ಏನು ಐಡೆಂಟಿಟಿ ಇದೆ ಲೂಸ್ ಮಾಡಲ್ಲಪ್ಪ. ಓಕೆ, ಸೇಮ್ ಅದೇ ತರ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಬ್ರೌನ್ ಪಿಪಿಟಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ನೆಸ್ಲರ್ಸ್ ರಿಯೇಜೆಂಟ್. ನೆಸ್ಲರ್ಸ್ ರಿಯೇಜೆಂಟ್ in the presence of Nestler's reagent. I'll write it down. I think it's not visible properly to you. Yes, ಇಲ್ಲಿ ಬರದಲ್ಲ 2NH4 ಏನಾಗಿರುತ್ತಲ್ಲ, ಓಕೆ, ಅದು ನೆಸ್ಲರ್ಸ್ ರಿಯೇಜೆಂಟ್ ಇಂದ ಆಗಿ ಬ್ರೌನ್ ಪಿಪಿಟಿಯನ್ನ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಏನಿದು? ನೆಸ್ಲರ್ಸ್ reagent. Clear? Nestler's reagent. Done. Next, complex compound. So double salt is done now. So double compound is done. Now we are going to learn about the complex. Understanding? Be active in the chat box. Don't forget to mark your attendance. Fast agi like buttons and hit ಮಾಡಿ ನೋಡೋಣ. Yes, you should learn these examples. Why? Because they are examples to make you understand the actually addition of reaction after the simple identity ana lose ಮಾಡ್ತಿಲ್ಲ, ಮತ್ತೆ ಹೇಗೆ ಅದು ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಸಿಂಪಲ್ ಸಾಲ್ಟ್ ಅನ್ನೋದು ಅದು ಇಂಪಾರ್ಟೆಂಟ್. ಅದಕ್ಕೆ ಅವ ಎಕ್ಸಾಂಪಲ್ಸ್ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೋಬೇಕು, ಆಯ್ತಾ? ಸೊ ಬಿಕಾಸ್ ಇನ್ KCET they will ask on those things the application based, ಅಂದ್ರೆ ಎಲ್ಲಪ್ಪ ಬ್ರೌನ್ ಪಿಪಿಟಿ ಆಗ್ತಿದೆ ಅನ್ನೋದು ಆ ತರ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳ್ತಾರೆ, ಅವಾಗ ಇದೆಲ್ಲ ಇಂಪಾರ್ಟೆಂಟ್, ಆಯ್ತಾ? Next comes the complex compound, where addition compound is which simple salts lose their identity and its aqueous solution does not give the test of its all constituent ions. But ಅಲ್ಲಿ ಏನಾಗ್ತಿತ್ತು, aqueous solution ಅಲ್ಲಿ ಎಲ್ಲ ಕೊಡ್ತಿತ್ತು, ಇಲ್ಲಿ aqueous solution ಅಲ್ಲಿ ಏನು ಕೊಡಲ್ಲ, ಆಯ್ತಾ? ಸಿಂಪಲ್. and it will be like what? It will lose its identity. ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ನಲ್ಲಿ ಅದರ ಐಡೆಂಟಿಟಿ ಏನಿದೆ ಅಲ್ಲ ಲೂಸ್ ಮಾಡುತ್ತೆ. ಸಿಂಪಲ್ ಸಾಲ್ಟ್ಸ್ ಏನು ಐಡೆಂಟಿಟಿ ಇದೆ ಅದು ಲೂಸ್ ಮಾಡುತ್ತೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನಾವು ಏನೋ ಸ್ಟೇಟ್ ಚಾಂಪಿಯನ್ ಇದ್ದೇವೆ, ಓಕೆ, ನಾವೀಗ ಸ್ಟೇಟ್ ಚಾಂಪಿಯನ್ ಇದ್ದೇವೆ. ಬಟ್ ಇನ್ ಕೇಸ್ ಈಗ ಎಲ್ಲ ಸ್ಟೇಟ್ಸ್ ಒಮ್ಮೆ ಒಂದು ಒಲಿಂಪಿಯಾಡ್ ನಲ್ಲಿ ಬಂತಪ್ಪ, ಇಲ್ಲಾಂದ್ರೆ ನ್ಯಾಷನಲ್ ಕಾಂಪಿಟೇಷನ್ ಅಲ್ಲಿ ಬಂತು, ಆ ನ್ಯಾಷನಲ್ ಕಾಂಪಿಟೇಷನ್ ಅಲ್ಲಿ ಎಲ್ಲಾ ಸ್ಟೇಟ್ಸ್ ದವ್ರು ಬಂದ್ರೆ ವಿ ವಿಲ್ ಬಿ ಲೈಕ್, ಇಫ್ ಇನ್ ದಿ ಕೇಸ್ ನಾನು ಕರ್ನಾಟಕ ಸ್ಟೇಟ್ ನಿಂದ ನಾ ಏನೋ ಒಂದು ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಿದ್ದೇನೆ ನ್ಯಾಷನಲ್ ಕಾಂಪಿಟೇಷನ್ ಅಲ್ಲಿ. ಸೊ ಆ ನ್ಯಾಷನಲ್ ಕಾಂಪಿಟೇಷನ್ ಅಲ್ಲಿ ನಂದು ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಇರಲ್ಲ, ಯಾಕಂದ್ರೆ ಎಲ್ಲಾ ಸ್ಟೇಟ್ ದವರು ಬಂದಿರ್ತಾರಲ್ಲಿ, ಫುಲ್ ಕಾಂಪಿಟೇಷನ್ ಇರುತ್ತೆ, ರೈಟ್? ಬಟ್ ಇನ್ ಕರ್ನಾಟಕ ಇಫ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಇಟ್ ಅಂಡ್ ಐ ಆಮ್ ಅ ಕರ್ನಾಟಕ ಮೀನ್ಸ್ ಸ್ಟೇಟ್ ಚಾಂಪಿಯನ್ ಐ ಆಮ್, ಅಂಡ್ ಆಫ್ಟರ್ ವರ್ಡ್ಸ್ ಇಫ್ ದ ಡಿಸ್ಟ್ರಿಕ್ಟ್ ಕಾಂಪಿಟೇಷನ್ ಇಸ್ ದೇರ್, ಅದರಲ್ಲಿ ನಂದು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ. ಸೊ ಅದರಲ್ಲಿ ಏನ್ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಡಬಲ್ ಸಾಲ್ಟ್ ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರಾ? ಸೊ ಈಗ ಇನ್ ಕೇಸ್ ನಾನು ಈಗ ನ್ಯಾಷನಲ್ ಕಾಂಪಿಟೇಷನ್ ಅಲ್ಲಿ ಸ್ಟೇಟ್ ವೈಸ್ ಹೋಗಿರುತ್ತಲ್ಲ, ಅವಾಗ ನಾವು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ಅಂತ ಕರಿತೇವೆ. ಕ್ಲಿಯರಾ? ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ಏನಂತ ಮತ್ತೆ double salt. So complex compounds don't lose their identity in the aqueous solution. So this is a simple example for that. Does not ionize to give the Fe2 plus and Cn minus ion. So whenever this is getting reacted with K4FeCN6 in the presence of 4K plus FeCN6 4 minus is been forming. Clear? Understood? One second guys. Yes, done. So this is the simple example which you should remember. Example is also important. ಎದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ಕೋಬೇಕಂದ್ರೆ ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಗ್ಬೇಕಲ್ಲ, ಇಲ್ಲಾಂದ್ರೆ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ ವೇಸ್ಟ್ ಆಗಿರುತ್ತೆ, ರೈಟ್? ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ ವೇಸ್ಟ್ ಆಗಿರುತ್ತೆ. Done. Let's move to the next part now. Next is classification of complex compounds. Next comes what? Classification of a complex compounds. Now we learned double salts also, double compounds also. Now complex compounds. In this complex compounds, we are going to learn about the classifications now. Okay, we are going to learn about the classifications. Wow, Abhishek late to the class. Revise ಮಾಡ್ಕೋಬೇಕು ಆಮೇಲೆ ಈಗ, ಆಯ್ತಾ? So first, classification of complex compound only. First thing is on basis of type of a ligand. Okay, yav tara type of a ligand is present. On that basis only, if the complex compound is going to be dependent. Okay, ligand yav tara ide, yav tara adu it's whether it is the strongest ligand or whether it is a weak ligand. Avunu nodkobekagutte. Clear? So first is about the on basis of the type of the ligand. In that we have two types. Okay, idನ್ನು flow chart ಆಗಿ convert ಮಾಡ್ಕೋಬಹುದು. Okay, ಇದನ್ನು ಫ್ಲೋ ಚಾರ್ಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಐ ವಿಲ್ ಟೆಲ್ ಯು. ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ಇದೆ. ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ಆಮೇಲೆ ಡಬಲ್ ಕಾಂಪೌಂಡ್ ಅಂತ ಹಾಕಿದ್ವಿ. ಡಬಲ್ ಕಾಂಪ್ಲೇನ್ ಐ ಕ್ಯಾನ್ ಟೆಲ್ ಯು ಒನ್ ಸೆಕೆಂಡ್. ಇಫ್ ಯು ವಾಂಟ್ ಐ ವಿಲ್ ಶೋ ಯು ಹೌ ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್ ಆಕ್ಚುಲಿ. ಓಕೆ, ಯಾವ ತರ ಮಾಡ್ಕೋಬಹುದು ಅದನ್ನ. Yes, first comes what? Addition compound anta barutte, right? Addition compound nalli ಎರಡು ತರ type ಕಲ್ತ್ವಿ ನಾವು. ಯಾವ ತರ ಎರಡು ತರ type ಕಲ್ತ್ವಿ? We have learned like two things. Double salt, then ಮತ್ತೆ ಇನ್ನೊಂದೇನು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್. ರೈಟ್, ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಅಂಡ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್ ನಾವು? ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರುತ್ತೆ? ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್ ನಲ್ಲಿ ಮತ್ತೆ ಟೈಪ್ಸ್ ಬರುತ್ತೆ. ಯಾವ ತರ ಟೈಪ್ಸ್ ಬರುತ್ತೆ ಅದನ್ನು ಮೀನ್ಸ್ ಇನ್ ದಾಟ್ ಓನ್ಲಿ ವಿ ವಿಲ್ ಗೆಟಿಂಗ್ ಟೂ ಮೆನಿ ಥಿಂಗ್ಸ್. कुछ समझ नहीं आ रहा. Salts and complex compounds. Yes, Yasin. So, ega on the basis of So, classification of complex compounds only on the basis of type of the ligand. Okay, on the basis of type of the ligand and degree of dissociation. Idralli ಏನು ಬರುತ್ತೆ? On the type of a complex compound. On the basis of type of a ligand. ಚಿಕ್ಕದ್ ಬರೀತೇನೆ. ಓಕೆ, ಡನ್. ಸೊ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ದ ಟೈಪ್ ಆಫ್ ದ ಲಿಗೇಂಡ್ ನಲ್ಲಿ ಏನ್ ಬರುತ್ತಪ್ಪ? ಮತ್ತೆ ವಿ ವಿಲ್ ಬಿ ಲರ್ನಿಂಗ್ ಅಬೌಟ್ ದ ಹೋಮೋಲೆಪ್ಟಿಕ್ ಅಂಡ್ ಹೆಟ್ರೋಪೋಯೆಟಿಕ್. ಓಕೆ, ಹೋಮೋಲೆಪ್ಟಿಕ್ ಇದರಲ್ಲಿ ಹೋಮೋಲೆಪ್ಟಿಕ್ ಒಂದಿದೆ, ಇನ್ನೊಂದು ಯಾವ್ದಿದೆ? ವಿ ಹ್ಯಾವ್ ಹೆಟ್ರೋಪಿಯೋಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ವಿಲ್ ರೈಟ್ ಇಟ್ ದೇರ್. ಸೊ ಲೈವೇ ತೋರಿಸ್ತಿದೆ ನಿಮಗೆ ಹೇಗೆ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡೋದು ಅನ್ನೋದು. ಸೊ ದ್ಯಾಟ್ ಯು ವಿಲ್ ಫಾಲೋ ದಿಸ್ ಥಿಂಗ್ಸ್ ಇನ್ ಯುವರ್ ಲೈಫ್, ಸೊ ದ್ಯಾಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ತಿಳಿತಾ? ಕ್ಲಿಯರ್? ಎಸ್, ವೆರಿ ಗುಡ್. ಹೋಮೋಲೆಪ್ಟಿಕ್ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಇರುತ್ತೆ, ಮತ್ತೆ ಹೆಟ್ರೋಪಿಯೋಟಿಕ್ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಇರುತ್ತೆ. ಡನ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಈ ಎರಡು ಕಲ್ತ್ವಿ ನಾವು ಇದರಲ್ಲಿ. ನಾವು ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ಟೈಪ್ ಆಫ್ ಲಿಗೆಂಡ್ ಆಯ್ತು. ಈಗ ಆನ್ ಬೇಸಿಸ್ ಆಫ್ ಡಿಗ್ರಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್ ಇದರಲ್ಲಿನೇ ಇನ್ನೊಂದು ಪಾರ್ಟ್ ಇರುತ್ತೆ. ಈಗ ಕ್ಲಿಯರ್? On the basis of degree of dissociation. Clear? ಇದೊಂದು ಆಯ್ತಾ? Understanding? Please, ma'am, English. Okay, on the basis of degree of dissociation is one, and one on the basis of type of ligand. Okay, so ಈಗ on the basis of degree of dissociation ಅಲ್ಲಿ perfect complex compound ಒಂದು ಮತ್ತೆ imperfect complex compound ಒಂದು ಕಲಿತೇವೆ. Perfect complex compound ಒಂದು, imperfect complex compound. Perfect complex compound and imperfect complex compound. Okay. So ಈ ತರ ಇದು ನೀವು ನೆನಪು ಇಟ್ಕೋಬಹುದು ಈಸಿಯಾಗಿ ಆಯ್ತಾ. ಸೊ see now addition compound is present. In that addition compound we will be learning two types, that is double salts and the complex compounds. In the complex compounds we will be learning on the basis of type of a ligand and on the basis of degree of dissociation. In that, on the basis of the type of the ligand, we have again two types. What are those? Haplolytic and heteroleptic complexes. And in the, on the basis of the degree of dissociation, on the basis of the degree of dissociation, okay, on the basis of the degree of dissociation, perfect complex compound annu kaliteve matte imperfect complex compound annu kaliteve. Clear? Understanding? So ee tara neevu idanna nenapitkobahudu. Done. This is no, see, very easiest one. Cycle idu, like you can tell it like flow chart also. Flow chart of addition compounds. Okay? Done? Yes. Easy to understand, right? So this is how you can do it. ಇದನ್ನ ನೀವು ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ. ಹಿಂಗೆ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವ ತರ ನೀವು ಅದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಮತ್ತೆ ಏನೇನು ಮಿಸ್ ಮಾಡಿದಾರಾ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಲ್ಲಿ. ವೈ ಬಿಕಾಸ್ ಸಮ್ ಟೈಮ್ಸ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಾವು ಇದು ಕಾನ್ಸೆಪ್ಟ್ ಏನೇ ಗೊತ್ತಿರಲ್ಲ, ಹೋಮೋಲೆಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂದ್ರೆ ಏನು, ಹೆಪ್ರೋಲಿಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂದ್ರೆ ಏನಂತ. ಸೊ ಆ ಟೈಮ್ದಲ್ಲಿ ಈ ಫ್ಲೋ ಚಾರ್ಟ್ ಅನ್ನ ನೋಡಿದ್ರೆ ಓಕೆ, ಐ ಹ್ಯಾವ್ ನಾಟ್ ಟಚ್ಡ್ ದಿಸ್ ಬೋತ್ ದ ಕಾನ್ಸೆಪ್ಟ್ಸ್, ಸೊ ಐ ಕ್ಯಾನ್ ಡೂ ಇಟ್. ಸೊ ನಿಮಗೆ ಫ್ಲಾಶ್ ಬ್ಯಾಕ್ ರಿವಿಷನ್ ಮಾಡ್ಲಿಕ್ಕೂ ಇಂಥ ಟೈಪ್ ಆಫ್ things will help you people a lot. Clear? Let's move to the next part now. Before that, we'll finish with the on the basis of the type of the ligand. So on the basis of the type of the ligand, first thing is going to come what? Homoleptic complex. So same type of ligands will be present there. Like example, this is going to be the central metal atom, that is also called as CMA. Central metal atom, that is also called as CMA. I'll just mark it. What is there inside here? I think it's not visible to you people, right? Okay. Yes. So in first example, you can check it out. Whatever the Cu means, once the square bracket is there, once inside that first ಏನ್ ಬರುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ? Central metal atom. That is going to be what? Central metal atom. Clear? Yes. So next comes what? That is going to be SO for NH34, where it is going to act like an ligand. ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್, ಬಿಕಾಸ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಅಂದ್ರೆ ಏನು ಮತ್ತೆ ಲಿಗ್ಯಾಂಡ್ ಅಂದ್ರೆ ಏನ್ ಕರೀತಾರೆ ಅವೆಲ್ಲ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಬಿಕಾಸ್ ಅದ್ರದ್ದು ನಾಲೆಜ್ ಇದ್ದಿರಲಿಲ್ಲ ಅಂದ್ರೆ ಯು ಪೀಪಲ್ ಕಾಂಟ್ ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದೆಮ್. ಓಕೆ, ಡೋಂಟ್ ಡೂ ಎನಿ ಅನ್ಯೂಸ್ಫುಲ್ ಥಿಂಗ್ಸ್ ಇನ್ ದ ಚಾಟ್ ಬಾಕ್ಸ್. Concentrate what I'm teaching. If you people know more than that, then don't come to the class itself. ನಮ್ಗಿಂತ ಶಾನೆ ಇದಾರಲ್ಲ ನೀವು, ಮತ್ತೆ ಏನು ಉಪಯೋಗ ಇದೆ? ಸುಮ್ಮನೆ ಅವನ ಜೊತೆ ಹಾಯ್ ಅಂದೆ, ಇವನ್ ಜೊತೆ ಹಾಯ್ ಅಂದೆ, ವೇಸ್ಟ್ ಅಲ್ಲ ಇದು ಬಂದಿಲ್ಲ ಕ್ಲಾಸ್ಗೆ. ಚೆನ್ನಾಗಿ ಕುಂತ ಓದ್ಬೇಕಲ್ಲ. ಎಕ್ಸಾಮ್ಸ್ ಅಂತೂ ಈಗ ಮಿಡ್ ಟರ್ಮ್ ಎಕ್ಸಾಮ್ಸ್ ಮುಗಿದ್ರೆ ಏನಾಯ್ತು, ಈಗ ಎಕ್ಸಾಮ್ಸ್ ಬರೋದಿದೆ ಅಲ್ಲ ಮತ್ತೆ, ರೈಟ್? ಪ್ರಿಪರೇಟರೀಸ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಯುವರ್ಸ್, ರೈಟ್? ಸೊ ಮೇನ್ ಎಕ್ಸಾಮ್ ಬರ್ತಿದೆ, KCET ಎಕ್ಸಾಮ್ ಬರೀ ಒಂದು 5 ತಿಂಗಳು ಓದಿದೆ. ಹೇಗೆ ಓದೋರು ನೀವು? Right? So please get motivated yourself and you need to sit and study. PPT will be available once the class is done. Okay? Understood? Yes. So example ಏನು ತಗೋಬಹುದು? Central metal atom, that is CMA, that is going to act like an Cu, that is copper, and NH34, that is going to act like an ligand. Done. Next comes the heteroleptic complex. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Different type of ligands are present. ಇಲ್ಲಿ same type of ligands are present in the homoleptic, but ಇಲ್ಲಿ heteroleptic complex ನಲ್ಲಿ there is a different type of a ligands. Like example, central metal atom ನಲ್ಲಿ PT ಇದ್ರೆ ಇಲ್ಲಿ ligand ನಲ್ಲಿ CH34 ಇದೆ. ಕ್ಲಿಯರಾ? ಸೊ ಅದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ? ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಅಂಡ್ ಲಿಗ್ಯಾಂಡ್. ಮೀನ್ಸ್ ligands will be different there. Okay, ligands will be different there. Okay, done. ಎಸ್ ಸೊ ಈಗ ಏನ್ ಫ್ಲೋ ಚಾರ್ಟ್ ಬರ್ದೆ ಅಲ್ಲ ಅದೇ ತರ ನೀವು ಎಕ್ಸಾಮ್ ಡೆಫಿನೇಷನ್ಸ್ ಅನ್ನು ಬರ್ಕೋಬಹುದು ಆಯ್ತಾ. ಹೇಗೆ ಬರ್ಕೋಬಹುದು ಅಂದ್ರೆ ಡೆಫಿನೇಷನ್ಸ್ ಡಬಲ್ ಸಾಲ್ಟ್ ಅಂದ್ರೆ ಏನಪ್ಪಾ ಡೆಫಿನೇಷನ್ಸ್ ಅಂತ ಬರ್ಕೋಬಹುದು. ಲೈಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಸಾಲ್ಟ್ಸ್ ಅಂದ್ರೆ ಡೆಫಿನೇಷನ್ಸ್ ಏನಂತ ಬರ್ಕೋಬಹುದು. ಅದ್ರ ತಳಗಡೆನೆ ಬರ್ಕೋಬಹುದು. ಒಂದ್ ಸ್ವಲ್ಪ ದೊಡ್ಡ ಪೇಪರ್ ತಗೋಬಹುದು. ಆ ಪೇಪರ್ ನಲ್ಲಿನೇ ಎಕ್ಸಾಂಪಲ್ ಮತ್ತೆ ಡೆಫಿನೇಷನ್ಸ್ ಎಲ್ಲ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಒಂದ್ಸಲ ನೀವು ಏನ್ ರಿವಿಷನ್ ಮಾಡ್ತಿರ್ತಾರಲ್ಲ ಆ ರಿವಿಷನ್ ಮಾಡೋಷ್ಟ್ರಲ್ಲಿ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್, on the basis of degree of dissociation, now we are done with the on the basis of the ligand type, and now we are going to learn about the degree of dissociation. Hi Sakshi. So perfect complex compound that is relatively more stable and its aqueous solution doesn't give test of its all constituent ions. It will not give the solution, means whatever is there no in relatively more stable ಏನಿರುತ್ತಲ್ಲ ಅವಕ್ಕೆಲ್ಲ its aqueous solution will not give a test of its all constituents ions. means ಯಾವ ತರ constituent ions ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಿದೆ ಏನಾಗ್ತಿದೆ ಅದ್ರದ್ದೆಲ್ಲ ಡೀಟೇಲ್ಸ್ ಕೊಡಲ್ಲ. ತಿಳಿತಾ? Understanding? Okay. So K3KCN which is getting reacted with copper cyanide in the presence of aqueous solution, we are going to get as K3CuCN4, where the Cu is going to act like a CMA, that is central metal atom, and Cn is going to act like a ligand. Okay, now people will understand it which is a ligand and which is the central metal atom. In the presence of aqueous solution, and we are going to get a separate, means ಏನಾಗುತ್ತೆ potassium separate ಆಗುತ್ತೆ ಆ whole compound ಜೊತೆಯಿಂದ ಆಯ್ತಾ. So 3K plus CuCN4 minus 3. Now perfect complex compound complication is going to happen in this way, okay, where Cu plus and S minus 2 is going to be less than KSP and no PPT is gonna have produced, means PPT will not be produced there when the reactions will be happening. Okay, practically in ಮಾಡ್ತಿರ್ತೇವಲ್ಲ ಅವಾಗ ಆಗಲ್ಲ because Cu plus is having a less concentration. Cu plus less concentration ಇದೆ, ಅದರ ಸಲುವಾಗಿ ಅದರದ್ದು PPT formation will not be happening. For Cn will be the side product which has been formed. Okay, can the cation and anion part be the, yes, cation and anion will be the part of the complex compound. Okay, it will be there. Okay, so only ಎಲ್ಲಾದ್ರಲ್ಲಿ ನೋಡ್ತಿದ್ರಲ್ಲ ಪ್ಲಸ್ ಇದೆ Cu ಪ್ಲಸ್ ಇದೆ Cn ಮೈನಸ್ ಇದೆ ಎಲ್ಲದರಲ್ಲೂ ಇದೆ -3 -2. if in case ions are not getting transferred then how it's possible, right? Next, imperfect complex compound. ಇಲ್ಲೇನಾಗುತ್ತೆ relatively less stable and its aqueous solution will give the test of its all constituent ions. So perfect ನಲ್ಲಿ ಕೊಡ್ತಿರ್ಲಿಲ್ಲ, ಇಲ್ಲಿ imperfect ನಲ್ಲಿ ಕೊಡುತ್ತೆ. ಓಕೆ, ಅದರದೇನು ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಇದೆ ಅಲ್ಲ ಅದೆಲ್ಲ ಕೊಡುತ್ತೆ imperfect ನಲ್ಲಿ. ತಿಳಿತಾ? So now 2KCN plus CdCN2, where K2CdCN4 in the presence of aqueous solution 2K plus CdCN4 minus 2, that is going to be the less stable there. Okay, now imperfect complex compound ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಸೇಮ್ ಅದೇ ತರ, just the complications are going to be forming there. Okay, if in case it is a more ionization, then we are going to get has Cd2 plus Cn, cyanide is going to be the side product. If you are going to pass a H2S gas, so avaga CDS which is going to be in the color of yellow PPT. So in form agutte yellow PPT form madutte. Clear? Yellow PPT form madutte imperfect complex ion nalli. Okay, imperfect complex ion nalli. ಎಲ್ಲಿದೆ ಅಮ್ಮ KSP? Where is the KSP? I don't know where is KSP, I forgot. Okay, so clear till here? CDS will be formed, that will be in the yellow PPT. Clear? So ಈ ತರ equations are form ಆಗುತ್ತೆ imperfect complex compound ನಲ್ಲಿ. It means what? In that it will be less stable because perfect ನಲ್ಲಿ ಅಂತೂ stable ಇರುತ್ತೆ completely, but ಇದರಲ್ಲಿ less stable ಇರುತ್ತೆ ಮತ್ತೆ its aqueous solution is going to give the test to all the constituents. Okay, ಎಲ್ಲ ion ಗೆ constituents ion ಗೆ ಕೊಡುತ್ತೆ. Clear? Next comes imperfect complex compounds which undergo 100% ionization is known as double salt. So in the case in case it is going, okay, in case it is going 100% ionization, okay, avಕ್ಕೆ ಏನು ಕರೀತಾರೆ double salts ಅಂತ ಕರೀತಾರೆ. Done. There is no sharp line between the perfect and imperfect complex compounds. Why? Because sharp line ಅಂದ್ರೆ ಈಗ ಲಕ್ಷ್ಮಣ ರೇಖಾ ಹಾಕ್ತಾರಲ್ಲ ಆ ತರ ಹೇಳೋದು. So sharp, it depends, okay, perfect ಮತ್ತೆ imperfect ಮೇಲೆ it depends how it's going to be happening. Clear? So there is no sharp line between the perfect and imperfect. It depends on how much constituent ions is being transferred from there. That is very important. ಇದನ್ನಷ್ಟೇ ನೆನಪಿಟ್ಕೋಬೇಕು perfect ಮತ್ತೆ imperfect ನಲ್ಲಿ. ಆಯ್ತಾ? Next, next comes complex forming. The tendency decreases down a group in S block because size is getting increased. So size is increasing. For that purpose, that complex will be formed. The tendency will start decreasing. Okay? Why? Because S block elements have a size, means S block element ನಲ್ಲಿ size increase ಆಕೊಂತ ಹೋಗ್ತಿದೆ. Okay? Size increase ಆಕೊಂತ ಹೋಗಿದ್ದಕ್ಕೇನೆ tendency will also start decreasing. Simple. Okay? Next, representation of a complex ion. How the representation of the complex ion is done. This is also very, very important, guys. So here the coordination sphere is present. This is the coordination sphere. You just think it like that. General equation it is. So where MLX in plus or minus T. I think it's not visible. I'll write it down. No problem. Okay. MLX plus or minus n, okay, MLX plus or minus n, plus or minus n, okay, where this m is going to A or T alphabet order, okay, A or T alphabet order. It's going to be what? A or T alphabet order, okay. Theta, understanding now? Yes. So what is going to be the outside region here? Ionization sphere is going to be the outside here. Free ion will be outside, like plus and minus ion ಬರ್ತಿದೆಲ್ಲ free ion. ಆಮೇಲೆ cation ಇರುತ್ತೆ. Cation means depends. Cation, anion, plus or minus, if it is giving the electron or taking the electron, depends on that we are going to write the ligand. Okay, this is what you need to remember. Next, naming of the ligand, how you are going to do it. Now you understood how the representation will be done. We'll take few more examples, then you'll have an idea. Okay, it's general like helide niಮಗೆ just ನಾನು. Now naming of the ligands is like O means dash O dash is going to be the suffix which is going to be provided to the name of the anionic ligands. So anionic ligands ಗೆ ಆ suffix ಅನ್ನು ಬರ್ಕೋಬಹುದು. ಆಯ್ತಾ? Next IUM. What is the IUM? ಇಲ್ಲಿ O ಇರುತ್ತೆ, ಇಲ್ಲಿ suffix ಏನಿರುತ್ತೆ? IUM ಇರುತ್ತೆ. Clear up? So IUM suffix provided to the name of the cationic ligands. Okay, provided to the cationic ligands. If in case it's 0, then it's going to be what? It's going to be the anionic ligands. Clear? If it's going to be the IUM, then it will be what? IUM and then cationic ligands. Clear? This is going to be the cationic ligands. Full yellow I bit with a dirty fellow. Okay. Then anionic ligands ending with the IDE are named as replacing the IDE with a suffix of O or replacing it with E by minus O. This is also important, guys. So ionic ligands ನಲ್ಲಿ ಏನಾಗುತ್ತಂದ್ರೆ ಅವಾಗ ಯಾವ್ದಾದ್ರೂ ಒಂದು ಎಲಿಮೆಂಟ್ ಎಂಡ್ ಆಗ್ತಿದ್ರೆ, ಓಕೆ, ಒನ್ ಸೆಕೆಂಡ್, ಯಾವ್ದಾದ್ರೂ ಎಲಿಮೆಂಟ್ ಎಂಡ್ ಆಗ್ತಿದ್ರೆ, ಒಂದು ನಿಮಿಷ, ಯಾವ್ದಾದ್ರು ಎಲಿಮೆಂಟ್ ಎಂಡ್ ಆಗ್ತಿದ್ರೆ, ಓಕೆ, ಇಫ್ ಎನಿಥಿಂಗ್ ಇಸ್ ಗೆಟಿಂಗ್ ಎಂಡೆಡ್ ದೇರ್ ವಿತ್ ದ IDE, ಓಕೆ, ವಿತ್ ದ IDE it is getting ended, those all are named by replacing it with IDE with suffix O. ಓಕೆ, ಎದರಿಂದ ಸಫಿಕ್ಸ್ O ದಿಂದ ರಿಪ್ಲೇಸ್ ಆಗುತ್ತೆ, ಅದೇನು IDE ಇದೆಯಲ್ಲ ಇದರಿಂದ ರಿಪ್ಲೇಸ್ ಆಗುತ್ತೆ. ಡಿಫ್ರೆಂಟ್ ಕಲರ್ ಇಂದ ಮಾರ್ಕ್ ಮಾಡಿದೆ ನೋಡಿ. ಓಕೆ, Yes, this will helpful for the boards also. Okay. So anionic ligand will ending with the ID. ಯಾವಾಗ anionic ligand ನಲ್ಲಿ IDE ಇಂದ end ಆಗುತ್ತಲ್ಲ ಪ್ರಾಡಕ್ಟ್ ಹೆಸರದು IUPAC ನೇಮ್ ಅಲ್ಲೆಲ್ಲ ಏನ್ ಚೇಂಜ್ ಮಾಡ್ತೀರಾ? We are going to change with the suffix as O. Or it is going to be replaced by minus E, so that is E only and O. Understood? This is very important. Important it is. Okay. Next, ligand whose name end in ITE, okay, whose end will end with ITE or ATE, it becomes ITO, okay, or ATO. It becomes ITO or ATO by replacing the ending it with minus E or minus O. By replacing it with minus E or with minus O. Done? Minus E with minus O. Next, classification of ligands on the basis of denticity, that is going to be the monodentate, polydentate, didentate, all those things will be learning it now. Clear? Understanding till here? Everyone understood? Tita Largo? Understood everyone with till here, everyone? Yes, now let's start with the classification of a ligands. Okay, this classification ligands only on the basis of denticity we are going to learn. That is inside denticity nalline first one irodu monodentic. Okay, so on the basis of monodentate ligands, neutral ligands which are present like H2O or NH3, which are in the form of aqueous medium, which are in the form of a liquid medium also, those all pH3, that is going to be the phosphate. One second guys. Yes, it's going to be the phosphine. NH3 will be amine. pH3 will be the triphenyl. Next comes the CO, carbonyl, you know. O2 will come the dioxygen. CS will come thiocarbonyl. Thiocarbonyl. N2 will come the dinitrogen. NO will come triosyl. So this is the structure they have given, one simple structure also. So pyridimine, this is also called as monodentate. Then CH3, NH2, methylamine, which this is also one structure which is they have given it. Those all are going to be included in the monodentate ligand. Okay, monodentate ligand. Clear? Monodentate ligand andre ಏನಪ್ಪ ಎಲ್ಲದರಲ್ಲಿ ಏನೇನಿದೆ ಅಲ್ಲ ಸಿಂಗಲ್ ಡೆಂಡೆಂಟ್ ಇರುತ್ತೆ, ಸಿಂಗಲ್ ಡೆಂಡೆಂಟ್ ಇರುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ಹೈಡ್ರೋಜನ್ ನೆವರ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಎನ್ bidentate ligand. So you should remember one exceptional here, that is hydrozyne. Okay, which is hydrozyne, that is NH2, that will never act like an bidentate ligand. Okay, that will never act as an bidentate ligand. That is also very, very important. Okay, next, cationic ligand. So next is comes what? Cationic ligand. Neutral ligands are done. Cationic ligands. So neutral andre completely they are neutral. They will never be a bidentate. They will never be a didentate also. Done. Next comes cationic ligand. Here O2 plus, that is also called as oxygenum. So NO plus, that is going to be the nitrosylium. O is going to be the nitrosonium nitrosonium. One second guys. Yes, O2 is going to be the oxazonium. NO plus is going to act as a nitrosemium or nitrosonium also. And NH2, that is just now I told you people, that is going to be the hydrozenium. Okay, so this is also important. Means you need to have an idea that neutral ligands ge yav tara examples ana kodbeku matte cationic ligands ge yav tara examples ana kodbeku. Once you start solving the things, no, if in case you have already learned this chapter, okay, allantu niಮಗೆ full easy ಆಗುತ್ತೆ. ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ ಐ ಗೆಸ್ ಇಟ್ ವಾಸ್ ದೇರ್ ಫಾರ್ ಯೋರ್ ಮಿಡ್ ಟರ್ಮ್ಸ್, ರೈಟ್? ಸೊ ಅವಾಗಂತೂ ನಿಮಗೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಬಹಳ ಚೆನ್ನಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ಯಾವ್ದಾದ್ರು ಕಾಲೇಜ್ನಲ್ಲಿ ಈ ಚಾಪ್ಟರ್ ಇನ್ನ ಅಂದ್ರೆ ಮಿಡ್ ಟರ್ಮ್ ಇರಲಿಲ್ಲ ಅಲ್ಲ, ಅವ್ರಿಗೂ ಇದು ಹೆಲ್ಪ್ ಆಗ್ಬೋದು. ಓಕೆ, now anionic ligands are going to be what? F minus, that is fluoride. Anionic means what? They are taking the electron or giving the electron? They are giving the electron. So F minus fluoride, or it is also called as fluoro, and S minus 2 will be the sulfido or sulfio. Now just I told you, if it is IDE, okay, if it is IDE, we are going to remove it and put it as O, where if it is an anionic ligand. Clear? If it is IDE, then we are going to replace it. We are going to replace it and put as O. Clear? We are going to replace it and put it as O. That is what I am doing. I am not doing anything extra here. ಏನು ರೂಲ್ಸ್ ಕಲಿಸಿದೆಲ್ಲ ಅದ್ರ ಪ್ರಕಾರನೇ ಎಕ್ಸಾಂಪಲ್ಸ್ ಇದೆ. ಓಕೆ, ಏನು ಚೇಂಜಸ್ ಇಲ್ಲ. ಒಂದು ಸ್ವಲ್ಪ ಎಕ್ಸೆಪ್ಷನಲ್ಸ್ ಇರುತ್ತೆ. ಆ ಎಕ್ಸೆಪ್ಷನಲ್ಸ್ ನೋಟ್ ತರ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್. ಓಕೆ, Cl minus, that is chloride, has become to chlorido or chloro also we can say it. Done. Then OH minus hydroxide or hydroxo also we can tell. Same like that, only bromide. Bromide is there, BROMIDE, right? That bromide is going to get converted into the bromo. Are you all understanding everyone? So you'll nodi. Okay, this bromide is there. ಇದೇನು IDE ಇದೆ ಅಲ್ಲ, ಇದು ಕನ್ವರ್ಟ್ ಆಗಿ O ಆಗ್ತಿದೆ. ಕ್ಲಿಯರ್? ವಾಟ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ಬ್ರೋಮೋ. ಲೈಕ್ ದ್ಯಾಟ್ ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಯು. ಓಕೆ, ಈ ಜಸ್ಟ್ ಹೇಳ್ದೇನಾ ರೂಲ್ಸ್, ಅದ್ರ ಪ್ರಕಾರ ಎಕ್ಸಾಂಪಲ್ಸ್ ಇದೆ. ಸೊ ದಿಸ್ ಆರ್ ಫ್ಯೂ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ವಿಚ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಇಟ್, ವಿಚ್ ಪೀಪಲ್ ಕ್ಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಟ್. ಮೀನ್ಸ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಅ ಐಡಿಯಾ ದಟ್ ವಾಟ್ ಟೈಪ್ ಆಫ್ anion ligands are there and what type of a cation ligands are present. Clear? Next, biodendant ligands. Now we are done with the monodendant ligands. In biodendant ligands, we have again 4 types of things. Okay, which are the first? Ethylene diamine. So next comes the dipyridine. Next comes the propane 1,2-diamine and the oxalate. Few more are there. We'll discuss one by one. Okay, biodendant ligand ನಲ್ಲಿ first one ಬರೋದೇನು? bidentate ಅಂದ್ರೆ ಏನು? 2. Okay, 2 are called as bidentate. Okay, now we studied about the monodendant. Monodendant, afterwards we are going to learn about the bidentate now. Clear? So in bidentate, ethylene diamine which is present, where it's going to be the suffix as en. En is the suffix here. Okay, where ethane, that is 1,2-diamine is present. Here what happens? Which type of complex it is? That is we need to know. Concentrate properly. It is a symmetrical complex compound which they have given it here. So here Mn plus 2, where it is getting bonded up with, okay, where it is getting bonded up with NH2 and CH2 with NH2 again, we are going to get a product in the, means we are going to get a chelate ring also here, plus N, means what? It is a cationic reaction. This is a cationic reaction, right? This is symmetrical complex. For that purpose, it will be En. Done. Simple. Clear? Clear? One second, guys. One second. Yes. Sorry. Let's start now. So first one is ethylene diamine and next comes what? Propane, where it is at 1,2-diamine, or it is also called as propylene diamine, where its suffix is going to be PN. Where it is going to be PN. Same ಅದೇ ತರ ಇಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. CH3 ಇದೆ. Same, ella changes, ಏನು changes illa, ella everything is same. Just the thing is here the CH3 was not there. Here we have a CH3. Clear? That is going to be 5-membered chelate ring. Okay? Illi ಎಷ್ಟು ring ittu? Just a normal chelate ring ittu. Illi 5-membered chelate ring is present. Okay? Here 5-membered chelate ring is present. Third one comes what? Dipyrimidine. That is also going to be the same symmetrical complex itself. Oh, sorry. It is also going to be the same symmetrical complex itself, but here also there will be a 5-membered chelate ring will be present. Next comes the oxalate. This all structures you need to remember. Ella structures na channa kunt odbeku, practice ಮಾಡಬೇಕು. ಮೇನ್ ಥಿಂಗು ಯಾವ ತರ chelate rings ಅನ್ನ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು, ಆಯ್ತಾ? So this is a 5-membered chelate ring. Here comes the oxalate, how it's going to be the structure of it. Next, same again, glycinate and even the dimethyl glycamate, that is also going to be the DMG. This is how the structures are going to be. Clear? Understanding? Yes. Next comes the polydentate ligand. First we learnt about the monodentate, bidentate. Next comes the polydentate. Polydentate means what? More than 2 is going to be the polydentate. Okay. Now all the bidentate and polydentate ligand are chelating ligands. Okay. Bidentate the monodentate bitbidi adalli chelating ring form agalla. Mono nalli chelating ring form agalla. Bidentate matte polydentate nalli ashte chelate ring form agodu. Clear? So illi enagtide all the biodentate and polydentate ligand are chelating ligands, and no chelate ring is equal to density minus 1. So it's actually number of chelate ring. Okay, number of chelate ring is actually equal to the density minus 1. This is how you are going to calculate it. Okay. Next comes first thing in that is diethylene triamine. That is also going to be the DIEN. That is also going to be what? DIEN. So here density is going to be 3 and number of the rings are 2. Illi one here 2 numbers of rings are there. 2 they have given. Density is going to be the 3. Clear? Density is going to be the 3. Then it is going to be the neutral as it is a DIEN. Okay. As it is a DIEN, it's going to be the neutral one. Clear? So this 2 chelating rings which are present, the rings which are present, that is what you are going to substitute. Okay. Number of the chelate rings are how many? 2. What is the density they have told? 3 minus 1. 3 minus 1 is how much? 2. 2 is equal to 2. Done. Simple, right? This is how you can understand the concept. Next comes the triene, that is also called as triethylene tetraamine, where the density is going to be the 4. Okay, 4 is there. Chelate rings are 3. Neutral it is. Same way you are going to substitute the equation and you are going to solve it. Clear? Next comes a tetrapyridine, that is also density is going to be the 3. Chelate rings are going to be 2 and that is also a neutral. Neutral yadake. Neutral all are mono. Okay, they are all monodentate. Okay, ethylene diamine tetrahydride, that is EDTA. This is also important. They have asked lot of times this question. Bayasala ee question kelidare. You need to practice it very well. Okay. Okay, I'll tell you how to prepare for NEET, so don't worry. So ethylene diamine tetraaceto, that is also called as EDTA minus 4, where there is going to be the 2 and density will be 6, 4 oxygens are present and the chelate ring will be 5 almost. Clear? So this is how the reactions is going to be. You can just check it out how many rings are present actually. 5 chelate rings are present. What are those 5 chelating rings? Oh, 5 are there, no? 1 second, guys. We have missed out somewhere. 1, 2, 3, 4, 5. Okay. Clear? So this is how the chelate rings will be. Done. Next, ethylene diamine triaceto, that is EDTA minus 3. This was actually EDTA minus 4 ittu, ಇದು minus 3 ಇದೆ. Same density will be 5 itself. Chelate rings will be also 4. And next comes the ambident ligands, where the ligands which have a 2 different donor atoms. Ligands will be having what? 2 different donor atoms. Okay. Donor atoms aired irutte. Tvita. Donor atoms aired irutte. Ambident ligands nalli donor atoms aired irutte. So now, but at a time of a coordination such as ligand, it can be coordinated, that is CMA, by either of the 2 atoms, by either of the 2 donor atoms. So that is going to be Mn plus, that is going to be C triple bond N, cyanido Cn, cyanoido, that is going to be the C, same adhe tara, O means they are replacing it by the O itself. They are replacing it by the O itself. So next one, same example they have given, that is about the nilito, nitrilo, nilito and nitrilo. So depends on which is actually, whether it is a monodentate, whether it is a bidentate or polydentate, depends on that the examples are going to work out. Next comes the dentate. Flexidentate is one word actually. It became double. Okay, one word. So ligand which can change the denticity, like example, we can change its denticity. Means what? We can change the shape of it. We have such compounds also where we can change the shape of it and we can change the chelating ring also. We can change the ring also. Clear? So few examples they have given here: CO3 minus 2, PO4 minus 3, SO4 minus 2, CH3, COO minus and NO minus. Clear? Examples what we can give: CONH3 5SO4Cl, where it's going to be the reaction in this way. Where is the chelating compound? You people know X plus 0 minus 2 will be 0, where X is going to be the plus 3 and the Cn is going to be the 6 here. When you substitute it, it's going to get to know that we are going to that it is a monodendant ligand. It's going to be what? Monodendant ligand. Tilita? Heg monodendant atu? 5 by NH3 ಇದೆ, 1 by SO4 ಇದೆ. Clear? So ಅದರ ಸಲುವಾಗಿ it's going to be the 1 by SO4 is there. So it will be a monodendant ligand. Next, on the basis of electron donating and electron accepting nature. So on the basis of what? Electron ಯಾವ ತರ donate ಮಾಡ್ತಿದ್ದೀರಾ ಮತ್ತೆ ಯಾವ ತರ accept ಮಾಡ್ತಿದ್ದೀರಾ, on that basis also it's going to work. So nature, first one we are going to learn is normal and classical ligands. ಏನಾಗುತ್ತೆ normal ಮತ್ತೆ classical ligands ನಲ್ಲಿ? Ligands which only donate the electron pair of central metal atom, donate the electron pair to central metal atom. Central metal atom. Okay, ಯಾವ ligands central metal atom ಅಷ್ಟೇ ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ. Okay, central metal atom ಅಷ್ಟೇ ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ and it forms the coordinate alpha bond. It forms the coordinate alpha bond. Simple ಆಗೇನು ligand ಇದೆ. Ligand ಎದಕ್ಕೆ ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ? It is giving to the central metal atom. Okay, ಆವಾಗ ಏನಾಗುತ್ತೆ? When it is gives to central metal atom, ಏನ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ? ಸಿಗ್ಮಾ ಆಲ್ಫಾ ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. Sigma 1 second. Okay. So example, NH2 minus OH minus N minus 3 Cl minus O minus 2. So these are the compounds which will actually, these ligands are there. These are actually the ligands which will actually donate the electron. ಇವೆಲ್ಲ ಏನು ligand ಇದೆಯಲ್ಲ ಕೊಡುತ್ತೆ electron. ಎದಕ್ಕೆ ಕೊಡುತ್ತೆ? Central metal atom ಕೊಡುತ್ತೆ. So ಆ central metal atom ಆಮೇಲೆ ಏನು ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ? Coordinate alpha bond will be formed there. Clear? Understanding? Simple to understand. ಭಾಳ simple lines ಇದಾವೆ. Understand ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ, definition ಬರ್ಕೊಳ್ಳಿಕ್ಕೆ ಭಾಳ ಈಸಿ ಇದು. ಆಯ್ತಾ? Next comes non-classical of pi acid or a pi acceptor ligands. Okay? Pi acceptor or pi acid or a pi acceptor ligands. You know what is the meaning of pi and sigma? Not necessary to repeat. Right? Everyone knows, no? What is that? ಯಾರ್ಯಾರಿಗೆ ಗೊತ್ತಿದೆ ಹೇಳಿ? ಪೈ ಮತ್ತೆ ಸಿಗ್ಮಾ ಅಂದ್ರೆ ಏನು? ಫಾಸ್ಟ್ ಯಾರಾದ್ರೂ ಡೆಫಿನೇಷನ್ ಹೇಳ್ಬೇಕು ಈಗ ನಂಗೆ ಜಸ್ಟ್ ಫಾಸ್ಟ್ ಆಗಿ. ಪೈ ಅಂದ್ರೆ ಏನು, ಸಿಗ್ಮಾ ಅಂದ್ರೆ ಏನು, ಡೆಫಿನೇಷನ್ಸ್ ಹೇಳಿದ್ರೇನೆ ಅಷ್ಟೇ ಗೊತ್ತಾಗೋದಿದು. ಈಗ ಫಸ್ಟ್ ಇಲೆಕ್ಟ್ರಾನ್ ಎದಕ್ಕೆ ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ? ಲಿಗ್ಯಾಂಡ್ ತಗೊಂಡಿದ್ದೇವೆ. ಆ ಲಿಗ್ಯಾಂಡು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ಗೆ ಕಂಪ್ಲೀಟ್ಲಿ ಡೊನೇಟ್ ಮಾಡಿದೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ. ಓಕೆ, ಯಾವಾಗ ಇಲೆಕ್ಟ್ರಾನ್ ಡೊನೇಷನ್ ಆಗುತ್ತಲ್ಲ ಅದ್ ಆದ ತಕ್ಷಣ ಕೋಆರ್ಡಿನೇಷನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್ಡ್. Right? Now, this same thing, is it happening when it is a pi acceptor or pi donator? That we need to understand here. Okay? ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ non-classical ನಲ್ಲಿ, or it is also called as a pi acid or a pi acceptor ligand ನಲ್ಲಿ, ligands which donate the electron pair to the central metal atom and it forms the coordination bonds. Okay? ಈ central metal atom ನಲ್ಲಿ ligands ಮತ್ತೆ ಕೊಡುತ್ತೆ central metal atom ಗೆ. Okay? ಏನ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ? coordinate bond ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. But simultaneously they accept the electron pair. They accept the electron pair from a cyanide through back bonding. That is also called as what? Synergic bonding. Simple way ಹೇಳ್ತೇನೆ. Okay? ಈಗ 3 ಫ್ರೆಂಡ್ಸ್ ಇದ್ದಾರೆ. Okay? 3 ಫ್ರೆಂಡ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್. ಆ 3 ಫ್ರೆಂಡ್ಸ್ ನಲ್ಲಿ ಯಾನೊಬ್ಬನ ಫ್ರೆಂಡ್ ಇದಾನಲ್ಲ, ಫಸ್ಟ್ ಫ್ರೆಂಡು, ಅವನು ಇನ್ನೊಬ್ಬ ಫ್ರೆಂಡ್ ಜೊತೆ ಇದನ್ನ ಮಾಡ್ತಾನೆ. ಓಕೆ, means 2 bonds, sigma means 1 bond. Yes, so okay, good. So ಈಗ 3 ಫ್ರೆಂಡ್ಸ್ ಇದ್ದಾರೆ. ಓಕೆ, ಅವ್ರಿಗೆ ಹೆಸರಿನ ಚೋಟು, ಮೋಟು, ಲೋಟು. ಸೊ ಚೋಟು, ಮೋಟು, ಲೋಟು ನಲ್ಲಿ ಮೋಟು ಇದನ್ನಲ್ಲ Motu is a friend of a Chotu also and Lotu also. But ಏನಾಗುತ್ತಂದ್ರೆ ಲೋಟು ಮತ್ತೆ ಮೋಟು ಇಬ್ರು ಫುಲ್ ನೋಟ್ಸ್ ಮಾಡಿರ್ತಾರೆ, ಪ್ರಿಪೇರ್ ಮಾಡಿರ್ತಾರೆ ಯಾವುದೋ ಒಂದು ಚಾಪ್ಟರ್ಗೆ. ಆ ಮೋಟು ಏನಿದಾನೆ ಚೋಟುದನ್ನು ನೋಟ್ಸ್ ತಗೋತಾನೆ, ಮತ್ತೆ ಸ್ಲೋಲಿ ಹೋಗಿ ಲೋಟು ಕಡೆಯಿಂದನೂ ನೋಟ್ಸ್ ತಗೋತಾನೆ. ಬಟ್ ಇವೆರಡು ಏನಿದಾರಲ್ಲ ಸೈಡ್ ಫ್ರೆಂಡ್ಸು ಚೋಟು ಮತ್ತೆ ಲೋಟು, ಅವರಿಬ್ರು ಗೊತ್ತಿರಲ್ಲ ಅವ್ನು ಎರಡು ಮಂದಿ ಕಡೆ ನೋಟ್ಸ್ ತಗೊಂಡಿದ್ದಾನೆ ಅನ್ನೋದು. ತಿಳಿತಾ? ಸೊ ದ ಸೆಲ್ಫಿಶ್ನೆಸ್, ಹೌ ದ ಸೆಲ್ಫಿಶ್ನೆಸ್ ಹಿಯರ್ ಇಸ್, ಸಿ ಈಗ ಡೈರೆಕ್ಟ್ ಲೈಕ್ ಕೊಡ್ತಿದ್ದಾರೆ, ಯಾರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಕೊಡ್ತಿದ್ದಾರೆ ಪೇರನ್ನ, ರೈಟ್? ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಬಿನ್ ಗಿವಿಂಗ್ ಫ್ರಮ್ ದ ಸೈನೈಡ್, ಬಟ್ ಆಲ್ಸೋ ಫ್ರಮ್ ದ ಬ್ಯಾಕ್ ಫ್ರಮ್ CN ಇಟ್ ಇಸ್ ಟೇಕಿಂಗ್ ಅಗೇನ್. ತಿಳಿತಾ? ನಾನು ಹೆಲ್ಪ್ ಮಾಡ್ತಿದ್ದೇನೆ, ಅದನ್ನ ಬಿಡ್ತಾರೆ, ಮತ್ತೆ ಇನ್ನೊಂದು ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಹೋಗಿ ಮತ್ತೆ ಬೇರೆ ಕಡೆನೂ ಹೋಗಿ ನೋಡ್ಬರೋದು, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ದ ಥಿಂಗ್ಸ್ ಆರ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್. ಕ್ಲಿಯರ್? ಅದಕ್ಕೆ ಸಿನರ್ಜಿಕ್ ಬಾಂಡಿಂಗ್ ಅಂತ ಕರೀತಾರೆ. ಎಕ್ಸಾಂಪಲ್ ಏನ್ ತಗೋಬಹುದು? CO NO plus CN minus C6H6 C5H5 minus and C2H4. Clear? These are all non-classic or a pi acid or a pi acceptor ligands. Clear? Simple understanding? Definition simple ಇದೆ ಅಲ್ಲ? This is also very important. Okay. Next comes the pi donor or pi acceptor ligand. So now what is the meaning of a pi donor? ನಾವೀಗ acceptation ಮಾಡ್ಕೊಂಡ್ವಿ, ನಾವೀಗ down ಡೊನೇಟ್ ಹೆಂಗ್ ಮಾಡ್ಕೊಳೋದು? ಓಕೆ, ಹೌ ಟು ಡೊನೇಟ್ ಇಟ್, ಹೌ ಟು ಡೊನೇಟ್ ಇಟ್. Pi donor and a pi acceptor ligand, where ligands which donate the pi electron to the central metal atom and also accept the electron density from the central metal atom through the synergic bonding. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ಲಿ ಸೆಂಟ್ರಲ್ ಅಟಮ್ ಇಂದ ಸಿನರ್ಜಿಕ್ ಬಾಂಡಿಂಗ್ ಇಂದ ಹಿಂದಿಂದ ನೋಟ್ಸ್ ತಗೋತಾರೆ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತಂದ್ರೆ ಯಾವ್ಯಾವ ಲಿಗೇಂಡ್ಸ್ ಅದಾವಲ್ಲ, ದೇ ವಿಲ್ ಡೊನೇಟ್ ದ pi electrons to the central metal atom. ಸಿಂಪಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ತೇನೆ ನೋಡಿ. ಸೊ ಲಿಗ್ಯಾಂಡ್ ಇದೆ, ligand will give electron to the central metal atom, electron ಕೊಡುತ್ತೆ central metal atom ಗೆ. Then afterwards what happens, the accept means the electron will be, ಈಗೇನು electron ಬಂದಿರುತ್ತಲ್ಲ ಇಲ್ಲಿ ಅದು accept ಮಾಡುತ್ತೆ, it will accept the electron. But why? Now it according to that acceptor electron also will have a density from the central metal atom. Okay, ಡೆನ್ಸಿಟಿನೂ ತಗೋತೆ, ಆ ಇಲೆಕ್ಟ್ರಾನ್ ಏನು ಬಂದಿರುತ್ತಲ್ಲ ಅದು ಅದರದ್ದು ಡೆನ್ಸಿಟಿನೂ ತಗೋತೆ. ಓಕೆ, ಡೆನ್ಸಿಟಿನೂ ತಗೋತೆ ಥ್ರೂ ದ ಸಿನರ್ಜಿಕ್ ಬಾಂಡಿಂಗ್. ದಿಸ್ ಆಲ್ ಪ್ರೊಸೆಸ್ ವಿಲ್ ಹ್ಯಾಪನ್ ವಿತ್ ವಾಟ್? ಸಿನರ್ಜಿಕ್ ಬಾಂಡಿಂಗ್. Okay, this much you should remember. Easy to remember. Okay. Okay. Next. These are the examples which they have given also here. You can just check it out. Heaticity, how it is happening. 6 pi electron donor is present. So in an easy way you will understand it. They have taken one sandwich dual. Okay. They have taken one compound here, CrN6 C6H6 ಅಂತ ತಗೊಂಡಿರ, where the sandwich compound is present, where the CN is going to be the 6, that is central CN is going to be the 6 here, where the heaticity which is happening here, where 6 pi electrons are getting donate, means it is giving the electron here 1 2 3 4 5 6, this has been giving the electron here. Understood? So it is giving the electron with the density. So accepts means what? Electron ಏನಿದೆ ಎಲ್ಲ ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ, it will even accepts the density, it will even accepts the density. Density ಅನ್ನೋನು accept ಮಾಡುತ್ತೆ. Clear? Next same example again they have given it here also. You can go through the one more example here which we have given it. Next comes the coordination number. Now coordination number is also very important concept which you should remember. Now total number of electron pair acceptor by CMA means central metal atom, where NiDmG square is going to be the 4 hazard central metal atom. Same ಅದೇ ತರ PT and Cl2 ಗುನು 4, PEDT ಗುನು 6 ಇರುತ್ತೆ, COEN2 ಗುನು OX Cl is going to be also 6. Now to remember this, some important points are present. Okay, coordination ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಸ್ವಲ್ಪ important points ಇದೆ. Okay, first one ಏನು, generally CN of the monovalent cation is 2. It's going to be how much? 2 and 4 accept. 2 is there and 4 except and CuCN minus ಏನಿದೆಲ್ಲ ಇದು OS plus 2 ಇದೆ CN 2 ಇದೆ. ಈಗ ಈ CN excess amount ನಲ್ಲಿ ಇದ್ರೆ CuCN 4 minus 3 that CN is going to be what? Coordination number ಏನಿರುತ್ತೆ 4 ಇರುತ್ತೆ. Done. It's going to be the 4 itself. Clear? Next. Generally, the coordination number of the bivalent cation is 4 and 6 except PT plus 2 and PD plus 2. Now, they will be having only 4. They will be having only 4 as its thing. Coordination number will be 4 itself. Then, generally, coordination number of a trivalent cation is 6 except some exceptionals are present. Okay, again exceptionals ide annu just discuss madidvi, that is CN of the trivalent cation is going to be 6 and the coordination number of central metal atom depends upon the charge of the CMA, whether it is going to be the plus 2 plus 3, anything depends on that only. It is going to be the central metal atom only depends on that. Okay, central metal atom adra mele depend agutte. Next comes what? Effective atomic number, that is also called as EAN. It is also called as EAN, where total number of electrons of CMA, which is present after accepting the electron pair from the ligands, accepting it from the ligand, from the pair of the ligand. Clear? From the pair of the ligand. Still I am seeing that many people have not marked the attendance. Fast attendance mark ಮಾಡಬೇಕು, and who are still then subscribed, and make sure to subscribe to the channel first. Okay, yes. Next ENA is going to be Z minus 0.5 plus 2 into CN. It's going to be 2 plus 2 into CN. Same ಅದೇ ತರ ಒಂದು example ನೋಡ್ಕೊಳ್ಳೋಣ. Okay, we'll see the example. Yes. We will tell, don't worry. We will tell how to prepare. I'll tell you. Don't worry. Yes, first example ನೋಡ್ಕೊಳ್ಳೋಣ. Oh shit. ಒಂದು ನಿಮಿಷ. Yes, first example, let us check it out. Here, K4FeCN6, where it is going to be the total amount of, that is going to be what? 26 minus plus 2 has its oxidation state, then 2 into 6 plus 2 has its oxidation state, and into 6, that is going to be how much? 36 Kr. Oxidation state is plus 2 and the coordination number is going to be the 6. Done. Coordination number is going to be the 6. Next comes one more. They have given K3FeCN6. Same way itself. There the 26 will be there. Oxidation state will be plus 3. Coordination number will be the 6. 2 into 6. That will be 35. Same adhe tara innondu example kodidare. You need to go through this properly. Next comes the Sedgwick rule. Next comes what? Sedgwick rule. What you need to understand is the Sedgwick rule. If in case EAN of CMA in metal carbonyl is equal to the atomic number of the nearest inert gas, then the stability of the metal is going to be high. Then the stability of the metal is going to be the high. Clear? If in case the EAN andre electron affinity nitrogen, that is going to be of central metal atom in the metal carbonyl is going to be equal. Yavag equal irutte? Atomic number main important ಇಲ್ಲಿ. Okay, atomic number of the nearest inert gas, like if in case helium, argon avara nearest one irutte namage, right? So our nearest gas du, then the stability of the metal will be becoming high. Means what? ಈಗ ಯಾರಾದ್ರೂ ಹೋಗಿ ಅಂಬಾನಿ ಜೊತೆ ಫ್ರೆಂಡ್ಶಿಪ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಸ್ವಲ್ಪ, then their mentality will increase. No, like example best Ori, ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಎಷ್ಟು ಮಂದಿಗೆ Ori ಗೊತ್ತಿದೆ ಅಂತ, but Ori, see, he is having a friendship with everyone, right? He is having a friendship with everyone. That is also one thing we can tell, right? So first example of that, what we can take, MnCO5 is actually less than CO5 minus because of its stability. So what will be the EAN? EAN will be here 35 and here the EAN will be 36. Clear? Same ಅದೇ ತರ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. It is more stable. Okay, it's going to be the more stable. Same here also iron carbonate also is cobalt also is given. That is also carbon oxide. It is neither oxidizing nor reducing. So Sedgwick rule is applicable only for the metal carbonyl. So Sedgwick rule is actually applicable only for the metal carbonyl compounds. Only for the metal carbonyl compounds. Clear? Understood? Next, EN of a polynuclear metal carbonyl. First question, same adhe tara, just they have given all the things. We need to draw the structures according to the things. Okay. Not really. First one, MnCO5 to EAN is equal to 35, where in the presence of dimer, MnCO 10. Okay, MnCO 10. Coordination number is 10 ಇದೆ ತಿಳಿತಾ. So what we are going to get sigma bond, that is going to be the 20. Clear how the structure is going to be? This is the structure, how you can consider it. Okay. Next comes 2COCO4, where the EN is going to be the 35. In the presence of dimer, CO2CO8 is there. Okay, CO2CO8 is there. Here it is 4, double of that 8. So the EAN will be what? 36. This is how the structure will be. Done? Next comes formula and IUPAC nomenclature of the coordination compounds. So formula, we'll see the examples also once we are done with the theory. Okay. Formula and the IUPAC nomenclature of the coordination compounds. Now what is the meaning of a formula of the complex? Okay. Formula of the complex andre enu? That is also plays a very important role. Okay. Adu bada important role play ಮಾಡುತ್ತೆ. ಆಯ್ತಾ? In a formula of both simple and complex salts, cation precedes the anion and no anionic, non-ionic compounds are written as single units. So, ಯಾವ್ಯಾವ non-ionic ಇದೆಯಲ್ಲ ಅವೆಲ್ಲ single unit ನಲ್ಲಿ ಬರ್ದಿರ್ತಾರೆ. Clear? Then complex ions are written inside the square brackets. So, ಯಾವ್ಯಾವ complex ions ಇದೆಯವಲ್ಲ ಎಲ್ಲ inside the square bracket ನಲ್ಲಿ ಬರ್ದಿರ್ತಾರೆ. Okay? See, these all are complex compounds. So, this all are written in the form of a square compounds. So, ivella idakke ಏನು ಕರೀತಾರೆ? This all are going to be like what? Where it went up? One second, guys. Okay. Complex compounds ಅನ್ನು ಕರೀತಾರೆ. Or compounds. Okay. Next are written inside the square brackets without any space between the ions, and the next is metal ions and the ligands are written in the following order. So metals ಮತ್ತೆ ligand ಯಾವ ತರ ಬರೀತಾರೆ? Central metal atom ಯಾವ ತರ ಬರೀತಾರೆ ಅದನ್ನ ನೋಡ್ಕೋಬೇಕು. Okay. In the complex part, the metal atom is written first. Okay. Metal atom will be written first. Okay. Next comes metal atom is written first, followed by a ligands in the order of anionic, neutral and cationic. Then afterwards what we are going to write? We are going to write with the metal atom ಬರದ ತಕ್ಷಣ ಏನು ಬರಬೇಕು? We should be following with the ligands. Ligands ಜೊತೆ follow ಮಾಡಬೇಕು. Ligands ಜೊತೆ follow ಮಾಡಿ in the order. Okay? ಯಾವ order ನಲ್ಲಿ ಬೇಕು? First ಇರೋದೇನು? First the anionic will be present. Then the neutral. Sorry, neutral spelling. Neutral. ಅದಾದ ತಕ್ಷಣ ಕ್ಯಾಟಯೋನಿಕ್. ಓಕೆ, ಕ್ಯಾಟಯೋನಿಕ್ ಬರಬೇಕು. ಓಕೆ. Next, if more than one ligand of the one type, that is anionic, neutral or cationic, are present, then they are arranged in the English alphabet order. Like example, between H2 and NH2, H2O should be written first, and similarly order of NO2 minus, then SO3 minus and OH minus will be written, and it will be written by the NO2 minus. Clear? Alphabetic order nalli A, B, C, D alphabetic order nalli ne baribeku. Clear? Understanding? ಯಾವ ತರ ಬರೀಬೇಕು ಅನ್ನೋದು? So if in case one ligand of the one type, like anionic ಇದೆ, neutral ಇದೆ, ಇಲ್ಲದ್ರೆ cationic ಇದೆ, are present, they are arranged in the English alphabetic order. If in case both the things are present, if both, if in case like these things are present, in the form of what you are going to write? In the form of alphabetic order you are going to write it. Okay. Okay, in the form of alphabetical order you are going to write it. Now example. Okay, example. Now example H2O and NH2 is there. H2O should be written first and then the NH2 will be coming. Now you need to do the ABCD alphabet and then check it. Okay. Next comes what? When the ligands of the same type have a similar name for the first atom, then the ligand with the less number such atoms will be written first. So ligands with the such atom means what? Yeah, we have ligand less number that will be written first. Okay, less number will be written first. Will be written first. Okay, it will be written first. Next, sometimes the second atom may be used to decide the order. Okay, sometimes second order also will be used to decide the order. Okay, when the number of the atoms are also same, example out of NO2 minus or NH2 minus will be written first. In H3 and N2 and NH3 will be written first as it contains only one atom. Means depends on the order also. Okay, it depends on the order also. Next comes polydentate ligands, and the observation for the ligands are always written in the lower case. Whatever the polydentate ligands are present, that will be written in the lower. It will be written in the lower case letters. Okay. One second, guys. Polyatomic ಯಾವಾಗಲೂ ಏನು ಬರೆದಿರುತ್ತಾರೆ? Polyatomic in a lower case. It will be written in the lower case. Clear? And later example like En, Py, etc. Okay, charge on the complex ion is represented as over script or a square bracket. So always these things will be written in the form of square brackets. It will be written in the form of what? Square brackets. Okay, square brackets. Understanding? Understanding? Yes. So example in Togobodu K or K4, they have taken example as K4, K4, Fe, Cn, 6. First cation and then the anion. Clear? Same again, negative ligand is present before the H2. Next comes the nomenclature of the coordination compounds. Nomenclature of the coordination compounds. Clear? So let's start with that. Let's start with this. Okay. Here nomenclature of the coordination compounds. Here the mononuclear coordination compounds are named by following these rules. So yavya mononuclear conditions ide alla avukella ಏನು follow ಮಾಡ್ತಾರೆ ಅನ್ನೋದು ಚೆಕ್ ಮಾಡೋಣ. So all this mononuclear coordination compounds are present. Those all are going to be named in a few rules which we are going to discuss now. Okay, few rules which are there that we will discuss. In both the positively and negatively charged coordination compounds, the cation is named first. Okay, first in baritare cation anna baritare. Cation will be written first and then the name of the central metal ion is written after the ligand are named as alphabetical order. So first we will write the cationic. Okay, cation is named the first, then the anionic, then afterwards the central metal atom is written after the ligand are named. Okay, ligand name ಮಾಡಿದ ತಕ್ಷಣ first ligand name ಮಾಡೋದು then central metal atom is going to be written. Okay, central metal ion atom is going to be written. Next, afterwards, this procedure is reversed in the writing its formula. Okay, it's reversed in the writing the formulas. Now, name of the anionic ligand is end with the O. Whatever the name anionic ligands are there with the anionic ligand with O, done. So in this way you should write it. Let's check it out how it's been written here. N3 minus, name of the ligand is azido. So symbol is going to be what? OH minus, then it is going to be the hydroxo. Cl minus andre chloro, that is CO3 2 minus andre carbonato. In this way you should mention the things. Clear? Next comes Br minus, there the bromo is there, SO4 minus 2, sulfato, then Cn minus means cyano, then SO3 minus 2 means sulfito, means O should be present. DE ತೆಗೆದು O ಅನ್ನ ಬರಿಬೇಕು. Next comes what? Name of the neutral and cationic ligands are the same except for aqua for H2O, amine for NH3 and carbonyl for CO and nitrosyl for NO. So these are the placed within the parentlessness. Okay, means in the bracket they will be written. Clear? So in bracket nil ಬರ್ದಿರ್ತಲ್ಲ ಅವೆಲ್ಲ. Like example ನೋಡ್ಕೋಬಹುದು, H2O which is giving aqua, then symbol is NO, then nitrosyl, NH3 andre amino, CS andre thiocarbonyl, then CO means carbonyl. Clear? Understanding? Next, positive ligands are named as. How the positive ligands will be named? NH4 plus 4 andre NO, NO plus andre nitrosylium, NH2, NH3 plus andre hydrozinium. So this, how in this way you people can concentrate. Okay, IUM. Okay, IUM. Next, oxidation state of the metal in the cation and anion or a neutral oxidation compound in a indicated by a Roman numerical parentless. So, ಏನೇನು oxidation state ಇದೆಯಲ್ಲ ಅಲ್ಲಿ +2 +3 ಅದೆಲ್ಲ ಅದನ್ನ Roman numbers ನಲ್ಲಿ ಬರಿತೇವೆ. Okay, 1 2 3 and that way. Okay, like when the complex ion is in cation, the metal is named same as the metal element. Example, CO is a complex cation and it is called as what? Cobalt, and PT is going to be what? Platinum. Clear? In an anionic, CO is called as cobaltate for some metals. Their Latin names are going to be used, that is complex anion. So in the complex anion, Latin words are going to be used. Okay, Latin names are going to be used. Example ಕೊಟ್ಟಿದ್ದಾರೆ ferrate, it is going to be the Fe. So nomenclature of the neutral complex molecules is done in the similar way as that of the complex ion. Okay, nomenclature of the neutral molecules on complex compounds ಅನ್ನೋನು ಹಾಗೆ ಆಗುತ್ತೆ. Okay, ಹಾಗೆ ಆಗೋದು. Ma'am, can I get the PDF after the session? Yes, you will receive the PDF. Okay. Next, the following examples and the illustration to the nomenclature for the coordination compounds. So, ಇದೇ ತರ ಇಲ್ಲಿ ನೆನಪಡ್ಕೊಂಬೇಡಿ ಹೇಗೆ ಬರೀತಾರೆ ಅನ್ನೋದು. Now, whatever the rules we have discussed, according to that one example they have given us. Okay. Here the first what we are going to write? Try. Try means what? Wherever the outside the name thing is there, that we are going to concept write. Try. Now next comes in the brackets which are present. Okay, amine. Clear? See, in the bracket amine is there. I'm written amine. Then next comes what? Tri-aquo. So next bracket is what? Tri ಇದೆ ಇದು. So this is tri amino. Done. I'll write it in different colors. Tri amino. Done. Again tri-aqua. Tri, done. Then comes what? Chromium. Now, what is the oxidation state? +3. So, for that purpose, 3 will be the Roman, and then at the outside it is chloride. Okay, at the outside is chloride. Clear? Yes. Next example. CONH2 CH2 CH2 NH2 3 2SO4 is named as. Try, yes, ethane 1, okay, ethane 1, 2 diamine, right, cobalt, Clear? First ಎಲ್ಲ ಕಾಮನ್ ಬ್ರಾಕೆಟ್ ಇದೆಲ್ಲ ಅದನ್ನೆಲ್ಲ ಬರ್ಕೊಂಡ್ವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್, ದೆನ್ ಆಫ್ಟರ್ವರ್ಡ್ ಸಲ್ಫೇಟ್, then sulfate, then yes, next comes what? AgNH3 AgCN2 is named as a dye edak barutte, it has been converted as a dye itself. Here 2 is present, amine, okay, amine, silver, Ag, silver. Clear? Then one dye, arginate 1. Okay, ligands which join two metals are known as a bridge ligands. Okay, ee tara in bridge ligands in form aguttalla, means this all called as bridge ligands. We will learn about the bridge ligands also in the KCET, because this is also important concept for the KCET. Okay, KCET ke bridge ligands ಬಗ್ಗೆ questions kelbohudu. Okay, so this is called as a bridge ligands, two metals which are being in the form of a bridge. Clear? Yes. Next comes the nomenclature of complexes. So here the cationic complexes which are present, like example, one second guys. Okay, nomenclature of the complexes. First comes the cationic complexes. How you are going to mention now? Triamino. First will come what? Triamine, triaqua, and chloronium 3 chloride. So the number of the individual ligands are indicated by the prefix like mono, di, tri, till tri, okay, etc. And ligands are named in the alphabetical order. Just now I told, if in case H2O and NH3 is there, then first you need to mention as NH2O, and then you are going to mention it as NH2. Okay, next, central metal atom and the oxidation state indicated by the Roman numeral is parentless, and the name of the ionizable ion is going to be present. And next comes the anionic complex. Cationic complex ಇದು ಎಲ್ಲರಿಗೂ ಸೇಮ್ ರೂಲ್ಸ್ ಇರುತ್ತೆ, ಡಿಫ್ರೆನ್ಸ್ ಏನು ಜಾಸ್ತಿ ಇಲ್ಲ. ಮೋನೋ, ಡೈ, ಟ್ರೈ ಅಂತ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಬೇಕು. ಫಸ್ಟ್ ಯಾವ್ದು ಅಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್ ನಲ್ಲಿ ಲಿಗೆನ್ಸ್ ಅನ್ನ ನೇಮ್ ಮಾಡ್ಕೋಬೇಕು. ಫಸ್ಟ್ H2O ಮತ್ತೆ NH3 ತಗೊಂಡಿದ್ವಿ, ಫಸ್ಟ್ NH2 ಮೆನ್ಷನ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ NH3 ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಯೋರ್ NH3 ಮೀನ್ಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಅಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್, ಯು ನೀಡ್ ಟು ರೈಟ್ ಇಟ್ ಡೌನ್. ಕ್ಲಿಯರ್? Next comes what? Anionic complex, that is also K3FeCN6. K3FeCN6, that is also potassium, hexa, anionic complex. Idu anionic complex nalli ಏನು ರೂಲ್ಸ್ ಕಲ್ತಿದ್ದೇವೆ ನಾವು? First we are going to write outside the compound what is present, right? Potassium, hexa, 6 hexa, cyano in the bracket, what is there? Cyano, or ferret 3, you people know what is the 3, right? Next, name of the ionizable metal and the oxidation state, then the name of the ligand in an alphabetical order, then the central metal atom plus ATE should be present. This central metal atom ATE should be present here. Okay, that should be present, and oxidation state, and its oxidation state. Clear? Next comes the magnetic nature, that is also first is ferromagnetic, FeCO and NO2, spin magnetic moment. This is the important formula guys. Spin magnetic moment, where mu is equal to, that is magnetic moment is equal to root of n plus 2 bm, that is bm is going to be the bond. Yes. Next, n is going to be to 1, mu is going to 1.73. ಹಾಗೆ ಯಾವ 2 ಇದ್ರೆ ಇಷ್ಟಿರುತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟು, ಸ್ಪಿನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟು. n is equal to 3 ಆದರೆ ಇಷ್ಟಿರುತ್ತೆ. Means you need to remember these things. You need to remember these things. Clear? Okay. So according to your periodic table, just a simple thing to understand, make you understand. Spin magnetic moment of a bivalent cation of 3D series. Okay, 3D series nalli yav tara spin momentum aagtide according to the formula I am telling you. Okay, if in case, okay, it is in case, so illi maximum spin magnetic moment irutte Mn ನಲ್ಲಿ. Okay, and diamagnetic when it is going to be 3d10 and Zl will be plus 2, then it will be a diamagnetic. Simple to remember, dn is equal to, okay, dn is equal to d10 minus n. In case n value will be 2, you think, okay, n 2 ಇದೆ, spin angle 2 ಇದೆ, to 2 t square is equal to 10 minus 2. Okay, that will be the spin magnetic moment for that. That will be the spin magnetic moment for that. Clear? Hi Janaki. Next, spin magnetic moment of the trivalent lanthanides are what? Na, that is neodymium, has a completely maximum magnetic moment among the lanthanides which are present, where the Na means Na is going to be the bestest one in the d orbitals. Okay, in the lanthanide orbitals, actually d only, that is due to the sum of the spin magnetic moment plus the orbital magnetic moment. Clear? So bonding complex compound, in the bonding complex compound we are going to learn about the Werner's theory. We are going to learn about the Werner's theory. I will be back in 5 minutes. I'll just have some water and come. Then we'll start with the Werner's theory. Clear? Then we'll start with the Werner's theory. Okay, I'm audible properly to everyone now. Just let me check it once. Yes, I'm audible. Let me check it once. Yes, let's start then. Yes, we had stopped in spin magnetic moment of the trivalent lanthanides, right? Trivalent lanthanides. Okay, so bonding in the complex compound, we need to start with the bonding in the complex compounds. Adralli first irodu Werner's theory. Adralli enirodu first Werner's theory. Use ma'am, please. Yeah. We'll use all the languages here. Okay. So Werner's theory nu bala important ide. This is also very, very important, guys. Don't idra mele short to KCET mele one question keltare. Okay. On this KCET is short question. Okay. On KCET it is a short question. So now Werner's theory, according to the Werner, central metal atom which has size, it is having a two types of valences. Okay. ಎರಡು ತರ valences ಇದೆ central metal atom ನಲ್ಲಿ. ಯಾವುದದು ಎರಡು ತರ valences ಇರೋದು? First is primary valency and next comes the secondary valency. Let me write it down for you. It's not visible properly, right? Primary valency. And next comes the secondary valency. Clear? Secondary valency. Now it's clear to everyone? Yes. So now primary valency and then secondary valency, where the primary valency is equal to the oxidation state of central metal atom. Okay. This is actually what? It's equal to the central metal atom. Whatever the oxidation state is there in the primary valency, adralli ella enagirutte equal irutte oxidation state at the central metal atom. Clear? Next comes the secondary valency. Here it is actually equal to the central metal atom. Sorry, it is equal to the coordination number of the central metal atom. Clear? Secondary valency nalli enagutte coord is equal to the coordination number. Illi it is equal to the oxidation state. Illi coordination number enide alla adu equal is that for the central metal atom. Clear? Next comes what? Satisfied by the anions. It is satisfied by the ligands itself. Clear? Then non-directional and ionizable. These are directional and non-ionizable. These are directional and even the non-ionizable. Clear? This is not helpful in the geometry prediction. This is helpful in the geometry prediction. Clear? So this is help means secondary valence is ashte helpful agutte. Geometrical means in structures tagitevalla aವಾಗ ಅಷ್ಟೇ help ಆಗೋದು. Okay, that is going to secondary valence ಅಷ್ಟೇ help ಮಾಡೋದು ನಮಗೆ diagrams ನಲ್ಲಿ. ಆಯ್ತಾ? Next comes what? All secondary valencies have specific arrangements according to the coordination number. According to the coordination number. So all the secondary valences will be having arrangements there according to the coordination number. Example in code. In case coordination number is 2. Okay. In case coordination number is going to be the 2, then it is going to act like a linear. In the geometry, it's going to be linear in shape. Clear? First of all, ಏನು ನೆನಪಿಟ್ಕೋಬೇಕಂದ್ರೆ ಸೆಕೆಂಡರಿ ವ್ಯಾಲೆನ್ಸಿಸ್ ಅಷ್ಟೇ ಜಾಮೆಟ್ರಿ ನಮಗೆ ಶೋ ಮಾಡುತ್ತೆ, ಪ್ರೈಮರಿ ವ್ಯಾಲೆನ್ಸಿ ಶೋ ಮಾಡಲ್ಲ. ಸೆಕೆಂಡ್ ಥಿಂಗ್ ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದ್ರೆ ಪ್ರೈಮರಿ ವ್ಯಾಲೆನ್ಸಿ ಅಂದ್ರೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ದು. ಸೆಕೆಂಡರಿ ವ್ಯಾಲೆನ್ಸಿನಲ್ಲಿ ಏನಿದೆ ಸೆಕೆಂಡರಿ ವ್ಯಾಲೆನ್ಸಿನಲ್ಲಿ ಎಸ್ ಇಟ್ಸ್ ಕರೆಕ್ಟ್. ಪ್ರೈಮರಿ ವ್ಯಾಲೆನ್ಸಿನಲ್ಲಿ ಏನಿರುತ್ತೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರುತ್ತೆ ಇಂಪಾರ್ಟೆಂಟು. ಸೆಕೆಂಡರಿ ವ್ಯಾಲೆನ್ಸಿನಲ್ಲಿ ಏನಿರುತ್ತೆ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಎಷ್ಟಿದೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತೆ. Clear? Coordination number ಎಷ್ಟಿದೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತೆ ಆಫ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್. ಕ್ಲಿಯರ್? If in case, okay, coordination number is going to be 3, then the structure is going to be the trigonal planar. Trigonal planar. If in case coordination number is 4, then it will be tetrahedral, or it is also going to be the square planar. Okay, it's going to be the square planar. ನಮಗೆ ಈಗ tetrahedral ಬರಿಬೇಕು square planar ಬರಿಬೇಕು ಮ್ಯಾಮ್ ಅಂತ ಕನ್ಫ್ಯೂಷನ್. ಸೊ ಅವಾಗ ಏನು ಮಾಡ್ಬೋದು ಅಂದ್ರೆ you people can do one thing there. Okay, depends on what compound they have given, depends on that you can change the shape of them. Okay, you can change the shape of them. Clear? Okay. Next, coordination number is 5 there, it is going to be TBP, there is tetrabutate planar, trigonal planar, and next comes going to be your square pyramidal. It's also going to be the square pyramidal. Clear? Next comes what? If in case coordination number is going to be the 6, then it's going to be the octahedral. Okay, it's going to be the octahedral. Clear? Clear? Understood everyone? Yavaga coordination number is 2, then it's going to be the linear. 3 idre bere color structure irutte, u ella l agutte, it's going to happen only in the secondary valences. Okay, secondary valences edri mele depend irutte, central metal atom is going to depend on what is the coordination number. Okay, central metal mele edri mele depend irutte, yav tara coordination number ideyala adar mele ashte depend irodu. Clear? Next, they have given one simple example also which we can go through. Okay, simple example annu kottidare. They have given cobalt H2O6Cl3. Okay, where the oxidation state is going to be the +3 and coordination number is going to be the 6. Okay, oxidation state +3 ide, coordination number irodu 6. Done. Primary valency is going to be the +3. Okay, primary valency enide +3 ide. Primary valency andre enappa? Oxidation state of a central metal atom. Enide oxidation state of central metal atom? +3. You have written +3. Then next comes secondary valency. Secondary valency means what? It depends on the coordination number. Coordination number enide ade secondary valency. That only we have written 6. Then satisfied by 3Cl. So they are having a chlorides are 3 actually here. Chlorides are 3 here. So there it is going to be satisfied by 6H2O. It's going to be satisfied by 6H2O. Done. 6H2O. Clear? Next, possible complex of CaCl3, 6H2O. Oxidation state again it will be +3 itself. Coordination number is also going to be 6. Then first one, CaH2O6Cl3. There the 4 ions will be present. Clear? COH2O5Cl, Cl2H2O. Outside enide, outside the bracket it is Cl2H2O ide. Avaga 3 ions irutte. It will be having a 3 ions. Same way, everything is same, but the number of molecules are 2H2O. Alli 1 H2O ittu, illi 2 H2O ide. Alli 2 ions irutte. Done. Next, COH2O3Cl3, that is 3H2O, that is not possible itself. So there the ions will only not be producing. Okay, there the ions will only not be producing. Same ade tara few examples they have given, oxidation states, and its you are going to write its coordination number. According to that you will have an idea that at the central metal atom whether it is going to be the primary or whether it is going to be the secondary one. Clear? Next comes what? In coordination compound. Yes, this is actually according to the NCERT. Okay, it's according to the NCERT. So to have an idea for you people that what type of things are going to be coming. Okay, in coordination compounds, metals show the 2 type of linkages, that is valencies like primary and secondary. Just now I discussed. Next comes the primary valencies are normally ionizable and are satisfied by the negative ions. Okay, and it is satisfied by the negative ions. All the primary valencies are normally, they are all normally ionizable. Ionizable means they will be always be donating the electron to someone, or they will be taking the electrons from someone. Okay, or they will be taking the electrons from someone and are satisfied by the negative ions. Negative ions means obviously it's taking the electron from someone. Clear? Then the secondary valencies are non-ionizable and these are satisfied by the neutral molecules. These are all satisfied by the neutral molecules or negative ions, and the secondary valencies is equal to the coordination number and is fixed for the metal. So coordination number andrene central metal atom's coordination number andrene secondary valency. Primary valency andre oxidation state. Aita? Next, ions or groups bound by the secondary linkages to the metals have a characteristic spatial arrangements corresponding to the different coordination numbers. That's what I told you. If it is 2, then it is going to be the linear, 3 and the square planar. Other than coordination number, according to that, you are going to get the geometry also. Okay, you are going to get the geometry also. Now, in modern formulation, such as spatial arrangements are called as coordination polyhedra. It's actually called as what? Polyhedra. Coordination polyhedra. Okay, and the species within the square bracket are coordination entities or complexes, and the ions outside the square bracket are going to be the counter ions. Understand this concept properly. So in coordination, now modern formulation and the spatial arrangement okay, and see a coordination polyhedra spatial arrangements are called as coordination polyhedra. But the yavya species square bracket nalli avukella coordination entities, or it is also called as complexes. Square bracket nalli avukella complexes, square complexes or coordination entities antanu karibahudu aita. And the ions outside the square bracket outside the square bracket like Cl2, Cl3 outside the bracket square bracket in the outside idu nodi. One second, yav example kottilla ikasile. No, it's there, no other example. I'll show it. These all things which are present, no, they are all counter ions. Okay, in outside the brackets ಏನದೆಲ್ಲ ಅವಕ್ಕೆಲ್ಲ counter ions ಅಂತ ಕರೀತಾರೆ. Done? Yes, last. He further postulated that octahedral, tetrahedral and square pillar geometrical shapes are more common in coordination compounds of transition metals. So these all are more common in the transition metals. Transition metals means you people know in the periodic table which are the transition metals and why they are actually, why? Because they are not satisfied. Okay, our transition elements satisfy agilla, ಅದಕ್ಕೆ electrons ಬೇರೆ ಕಡೆಯಿಂದ ತಗೋತಿರುತ್ತೆ. They are taking the electrons from someone. They are not happy. They are not completed their octet only. So they are trying to take the electrons from someone. For that purpose, this transition elements will more participate in the coordination number. Simple way to understand. Idu one give reason tara question keyabohudu. Aita. Next, thus CONH363 plus COClNH352 plus. So ee tara examples ana nodko bahudu. Now, who is that behind this person of the coordination compound is? Okay, who is this person or behind the coordination compound? This is the person. I don't know how much visibility is there, but in your NCERT book, this person's photo is there. If you want, you can go and check it out also. Okay, yaar avan mansha ಇದನ್ನ ಮಾಡಿದಾನ ಅನ್ನೋದು ನೋಡ್ಕೋಬಹುದು ಆಯ್ತಾ. So this Werner was born in December 12. He was actually born in December 12. So ಇದನ್ನೇ ಅದಕ್ಕೆ ಓದ್ತಿದ್ದೇನೆ ಮ್ಯಾಮ್, ಇದೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆನಾ KCET ಗೆ ಅಂತ ಸ್ವಲ್ಪ ಮಂದಿ ಕೇಳ್ತಾರೆ. ಸೊ ಇದು ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ, ಅದಕ್ಕೆ ಓದ್ತಿರೋದು. ಓಕೆ, ಸೊ Werner was born on the December 12, 1866 in the Mulhouse, a small community in the French provinces of Elsass. He studied the chemistry began in the Karlsruhe in the Germany and continued in Zurich, that is Switzerland, and where in this doctoral thesis, like example 1819 alli, he explained the difference in the properties of certain nitrogen connecting the organic compounds, okay, substances on the basis of isomerism. Now he extended the want of theory. Okay, ಏನು extend ಮಾಡ್ಕೊಂಡಾನ, want of theory ಅನ್ನ extend ಮಾಡ್ಕೊಂಡ. Want of theory ಅನ್ನ understand ಮಾಡ್ಕೊಂಡ ತಕ್ಷಣ he got to know about the Werner's theory there itself with the help of those inventions which he has trying to do it. Okay, ಆಮೇಲೆ at the age of 29 years become a full professor at the Technik and Hochschule in Zurich, and in 1895 Alfred Werner was also a chemist and educationist, like we are educationist ಅಂದ್ರೆ ರಿಸರ್ಚ್ ಮಾಡ್ತಿರ್ತಾರೆ ಮತ್ತೆ ಕಲಿಸ್ತಿರ್ತಾರೆ ಸಕಟ್ಟು ಆಯ್ತಾ. And this theory in which Werner proposed the relativity ideas about the how atoms and molecules are linked together was formulated in the span of only 3 years. So in the year of 1890 to 1893, in that year span only, actually he introduced the linkage between the atoms and molecules. Okay, then he became a first Swiss chemist to win the Nobel Prize also, when he won the Nobel Prize in 1913 for his work on the linkage of atoms and the coordination theory. Clear? This is also very important. Why important is, actually they have asked one question from there. I don't know, even some people were shocked when they heard about it. So, but this type of things also will be asking. So, only 100 times most of the teachers will tell you, people, please read the NCERT book for the KCET purpose line to line. Okay, line to line ಚೆನ್ನಾಗಿ KCET book na perfect ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ KCET ಬಹಳ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ನಿಮ್ಮದು, ಆಯ್ತಾ? Next comes the VBT, that is also called as valence bond theory. Okay, let's start with the valence bond theory. Now, central metal atom releases almost the electron according to its oxidation state. So, central metal atom will release the electron according to its oxidation state. Obviously, because oxidation state they are dependent, actually it's going to release it, right? Dependent on that only it's going to release, right? One second, guys. Okay, it's going to release. Now, central metal atom will provide the vacant orbitals according to its coordination number. So, this central metal atoms which are present, it will provide the vacant orbitals according to its coordination number only. Okay, ಯಾವಾಗ vacant orbital provide ಮಾಡುತ್ತೆ, ಯಾವಾಗ coordination number means it is 2 ಅಂದ್ರೆ ಏನಿರುತ್ತೆ, 3 ಅಂದ್ರೆ ಎಷ್ಟಿರುತ್ತೆ, ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದು. Okay, now this vacant orbital undergoes the historian and forms the coordinate sigma bond with the donor atoms. Obviously the bonding should be there. No, ಈಗ ನಾ ಕೊಡ್ತಿದ್ದೇನಪ್ಪ ಎಲೆಕ್ಟ್ರಾನು, ನೀ ಎಲ್ಲಿ ಹೋಗಿರ್ತೀಯ? ಸಿ ಈಗ ನಾನು ನಿನ್ನ ಮನ್ಯಾಗ ನನಗೆ ಒಂದು I am giving you one fridge, new fridge ಕೊಡ್ತಿದ್ದೇನೆ. ಓಕೆ, ಹೊಸ ಫ್ರಿಜ್ ಕೊಟ್ಟಿದ್ದೇನೆ, ನೀವು ಎಲ್ಲಿ ಹೋಗಿರ್ತೀರ ಅಕಸ್ಮಾತ್ ಫ್ರಿಜ್ ಜಾಗ ಇದ್ದಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ? ಸೊ ಜಾಗ ಮಾಡ್ಬೇಕಲ್ಲ, ನೀವು ಜಾಗ ಮಾಡ್ಬೇಕು ಮನೆಯಲ್ಲಿ, ಇಲ್ಲಿ ಫ್ರಿಜ್ ಇರ್ಬೇಕಂಪ ಅಂತ, ರೈಟ್? ಸೊ ಇದನ್ನ ಜಾಗ ಮಾಡಬೇಕು ನೀವು ಫ್ರಿಜ್ ಇಡ್ಲಿಕ್ಕಂದ್ರೆ, ಮೀನ್ಸ್ ಬಾಂಡಿಂಗ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಸೇಮ್ ವೇ ಹಿಯರ್ ಆಲ್ಸೋ. ಸೊ ಇಟ್ಸ್ ಗಿವಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್, ಬಟ್ to go and stay there, to get a bond there, we need no energy is necessary there, right? That is what it will be dependent on. Okay, ali sigma bond formation agutte in between to get bonded. Okay, friendship start agutte, hosa friendship, aita? Next, hybridization state of a central metal atom depends upon the coordination number also, and the nature of the ligand, and a molecular momentum, dipole momentum, and isomerism, etc., and are also helpful in the hybridization prediction also. Yes, this will also help us to predict that what is its hybridization. Okay, yeah, sure, we will speak. Okay, so coordination number is going to be the 2, then it will be which hybridization? SP hybridization, and they will be linear. In geometry irutte, linear will be the geometry. Next comes the coordination number 3. If the coordination number is going to be 3, then it will be SP2 hybridization. Those all will be geometry will be having a trigonal planar. Then same coordination number 4, SP3, it will be, that will be tetrahedral. And same way only, if the coordination number is 4 itself, here the DSP2 hybridization is also possible, because one electron might donate to the d orbital also. Okay, that is called as what? Square planar. Okay, sp3 idre trihedral, ಮತ್ತೆ dsp2 idre square planar. So ಈ ತರ ನೀವು ಇದನ್ನ ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಟ್ರೆ, ಓಕೆ, ಈ ತರ ನೀವು ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಟ್ರೆ, ಯಾಕೆ ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹಿಂಗೆ ಬರ್ಕೊಂಡಿದ್ದೇನೆ? ಬಿಕಾಸ್ ಇದನ್ನ ಯಾಕೆ ಹಿಂಗೆ ಡೈರೆಕ್ಟ್ ನಿಮಗೆ ಬರ್ದು ಈಸಿಯಾಗಿ ಹೇಳ್ತಿದ್ದೇನೆಂದ್ರೆ, it will really help you people to the KCET level. Okay, ನಂಗೆ ಗೊತ್ತು ಬೋರ್ಡ್ಸ್ ನಲ್ಲಿ ಫುಲ್ ನೀವು ಡೀಟೇಲ್ ಆಗಿ ಬರಿಬೇಕು, ಬಟ್ KCET ನಲ್ಲಿ ಈಗ ಏನ್ ಶಾರ್ಟ್ ಕಟ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಅನ್ನ, ಯಾವ ತರ ಶಾರ್ಟ್ ನೋಟ್ಸ್ ಅನ್ನ ಮಾಡ್ಕೋಬೇಕು, ಅದರಿಂದ ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ರಿವಿಷನ್ ಮಾಡೋ ಟೈಮ್ದಲ್ಲಿ. It's not necessary there like full theory you are going to sit and write, right? Just now 4 ಆಪ್ಷನ್ ಅಲ್ಲಿ ಒಂದೇ ಟಿಕ್ ಮಾಡ್ಕೊಂಡ್ ಬರಬೇಕು, ಅದು ನೆಗೆಟಿವ್ ಮಾರ್ಕ್ಸ್ ಹಂಗಿಲ್ಲ. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಅದ್ರ ನಾಲೆಜ್ ಸ್ವಲ್ಪ ಇರಬೇಕಲ್ಲ. ಸೊ ಫಾರ್ ದಟ್ ಪರ್ಪಸ್ ಐ ಹ್ಯಾವ್ ಮೇಡ್ ಇಟ್ ವೆರಿ ಈಸಿಲಿ to make a revision. Okay, in case ನೀವಾದ್ರೂ KCET ಗೆ ಈಗ ನಾವು PYQ ಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದಾನೆ ಈ ವೀಕೆಂಡು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ ಮೇಲೆ. ಓಕೆ, ಈ ಲೆಕ್ಚರ್ ನೋಡ್ಬೋದು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್, ಮತ್ತೆ ಕುಂತ್ PYQs ಕುಂತ್ ಸಾಲ್ವ್ ಮಾಡಿ ಎಷ್ಟು ಬೇಕಷ್ಟು ಆರಾಮಾಗಿ ಬರುತ್ತೆ. ಇನ್ ಕೇಸ್ ಯು ಹ್ಯಾವ್ completely watched the lecture then only. Okay, Yes, this is about the VBT. One second. Yeah. Now, if in case coordination number is going to be 5, then it will be sp3d, then it will be trigonal, bipolar, pyramidal, and dsp2 andre TBP ne irutte, matte square pyramidal, that is going to be the dx square y square. Now, if in case again coordination number will be 6, then the hybridization will be sp3d2 and d2sp3, and here the octahedral combination will be there, geometry will be there, and here also octahedral geometry will be there. If in case it is a sp3d2 and d2sp3, okay, and d2sp3. Clear? Now, in the presence of a strong filled ligand yavagide, avaga the pairing of n-1d electron is actually possible before the hybridization. It's actually possible before the hybridization, but this pairing is not possible in the presence of WFL. It's not possible in the weak filled ligand. Okay, this is not possible in the weak filled ligand. But L possibility irutte, only in the strong filled ligand it will be possible. Clear? Next comes S or S, that is only donating the electron. O donor, this is the N donor, and this is the C donor. Clear? This also, which means you need to have an idea now which are weak filled ligands and strong filled ligands. This is some small examples which I have written it. You can go through this concept properly. Okay. Next, all ligands acts as an SFL with 4D and 3D series metal ions, like all the ligands which are present, all are strong filled ligands itself, and with 4D and 5D series metal ions. Okay, yav strong filled ligands idalla avella 4D matte 5D series nalli irutte. 4D 5D series of metal ions. Okay, metal ions, don't forget the metal again. Okay, P acts as a strong filled ligand with the Ni +4. So, adhe tara remaining things also will start acting according to that. Clear? Yes. Now we have a few examples. One second, guys. Few examples which you people need to know it. Okay. Few examples. I am not going to solve all the examples, but I have given you most of the 10 to 15 examples I have given it. You people can go through it, all of them. Okay, you people can go through it, all of them. Let's start. First one is NiCN4 - 2. Oxidation state is going to be the +2 and coordination number is going to be the 4. Okay. Now, ligand is going to be the strong filled ligand. Which are the strong filled ligand? That is wherever the cyanide, nitrogen, all those things will be present. That are all strong filled ligands. Okay. Now, Ni is going to be 3D8 4s2. The configuration, electronic configuration, 3D8 4s2. Now, we need to do the possibility. Okay. D andre eshtu irutte? 1, 2, 3, 4, 5. D andre eshtu boxes tegibeku? 5 boxes. Okay. S means 1. S means 1, P means 3, D means 5. Ishtu nenipettukolli. Okay. Now, pairing, let's start with the pairing now. D is actually having 8. First 1, 2, 3, 4, 5. Done. 6, 7, 8. Done. 4 S nalli 2 are there. 2 are there. Right. 1, 2. Done. So, this is done. Okay. Now, Ni +2 nalli, 3D nalli same irutte. Now, the pairing means the electrons is being getting transferred here. The electrons are getting transferred here. Okay. Then, what is going to happen here? This box will be remaining one. Okay. So, for that purpose, when it will come this side, D will remain D. Yes, ide. Yes. Then comes 2. Clear? DSP2. Done. Square planar, and it is going to be the dimagnetic. Dimagnetic. Clear? Next one, NiCl4 minus 2 or NiSCN4 minus 2. Okay, concentrate here. Oxidation state is going to be the plus 2 itself. Coordination number is going to be the 4 itself. Coordination number is going to be 4. Ligand will be weak filled ligand. Yes, we need to understand which are weak ligand and which are strong ligands also. So this is how the combination, no pairing will be happening here in the Ni2 plus 2. So 3D series nalli. So we are going to get what? sp3, tetrahedral and paramagnetic. Next comes which FeCO5 for Dm is going to be 0 here. Oxidation state is 0. Cn is going to be 5 and the ligand is strong filled ligand it is. So how the transfer of the ligands are going to happen? Here the pair of ligands are present. It will come and stay here. Clear? Understood? So how much is remaining now? D will remain here. dsp3. Done. Say MnCl4 minus 2 sp3 ಇದೆ. So ಇಲ್ಲಿ ನೋಡಿ oxidation state plus 2, coordination number 4, ligand is a weak filled ligand. 3D series ನಲ್ಲಿ D ನಲ್ಲಿ ಎಷ್ಟು ಹಾಕಬೇಕು? How much we have in the D? We have almost 5. 1, 2, 3, 4, 5. Done. Now only sp3 is remaining. sp3 will be the hybridization, that is going to be the tetrahedral paramagnetic. You can find the mu also. You know already the formula of the mu. We have solved this problem, so I am not solving with the mu one. Okay. CuCl5 minus 3 sp3d, that is also going to be sp3d hybridization, where the oxidation state is going to be plus 5, coordination number is going to be the 5, ligand is weak filled ligand. So 3D is present, weak filled ligand is the 1, 2, 3, 4, 5, 6, 7, 8, 9. Done. 3D 9, done. 4s is there, it's not going to be possible, nothing is there. 4p, then 4d, that will be sp3d. Clear? Same other there are few more examples I have given, lots of examples are there. Go through the examples properly everyone, because these examples VBT ಮೇಲಿಂದ just short ಆಗಿ KCET ಮೇಲೆ question ಕೇಳ್ತಾರೆ. So I have given 4 to 5 questions extra for you people, which you people just see the question ಮತ್ತೆ ಆಮೇಲೆ answer ಅನ್ನ solve ಮಾಡಿ ಆಯ್ತಾ. Next important concept is drawback of VBT, which is very important guys. So it can't explain the stability of the complex compound. Clear? Complex compound du stability explain ಮಾಡ್ಲಿಕ್ ಆಗಲ್ಲ ಆಯ್ತಾ. Next, it can't explain the color of the complex compound. So ನಾವು ಈಗೇನು VBT ಮಾಡಿದ್ವಲ್ಲ, ಅದರಿಂದ ನಮ್ಗೆ ಯಾವ ಕಲರ್ ಇದೆ, ಯಾವ ಕಲರ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. Next, it can't explain the electron transference, it can't explain. Then it can't explain pairing of n minus d electrons. But it does not give any criteria for the classification of a strong filled ligand and a weak filled ligand. Means what? We can't understand according to the VBT that whether that compound is going to be the strong filled or whether that compound is going to be the weak filled. Ad namak gottagalla. Clear? We won't get it. Clear? These are the drawbacks. On drawbacks also, important it is, they have asked lot of times these questions in the KCET. Done. Next comes the crystal fill theory for the octahedral complex. How the crystal fill theory will be there in the octahedral complexes. Concentrate properly now. Okay. dxy, dyz and tzx all are called as T2G. Okay. T2G is going to be what? dxy. Okay. dxy. This is different. This is dxy. First, let us finish this with dxy, dyz and dzx. It's going to be considered as what? T2G. It's going to be considered as T2G. Done. Now, next comes dz square, dx square minus y square is going to be considered as Eg. ಇವಕ್ಕೆಲ್ಲ ಏನು ಕರೀತಾರೆ? Eg. Crystal fill theory T2G ಅಂದ್ರೆ dxy, dyz and dz square. Done. So, next comes the Eg. Eg is going to be considered as dz square. So sorry guys. So dx square minus y square. Done. So this is going to be the dx square minus y square and this is dxy. Okay, now how the splitting will be done, how this is very important guys, how the splitting will be done and how it's very important. Yes. Now this is a free state is there. Okay, there is a no splitting at the starting time. Okay, there will be no splitting at the starting point. Clear? Now how the splitting will be done? Okay, then now first when the free state will be there, those compound will be distributed in the two things. It will be distributed in the two things. First one is what? Eg. Second one is T2G. Clear? Eg and T2G. Okay, Eg and T2G. Here Eg, that is dz square and d square, dx square and dy square. Okay, dz square and dx square minus y square. So this will be present in the Eg. T2G nalli eniruttappa, T2G nalli enirutte dxy, dyz and dz square. Okay, dxy, dyz and dxz. Okay, these are present in the T2G. Now you need to remember is what is the difference now? In difference ide means what? Distance eshtiде ಅನ್ನೋದು ನೆನಪಿಟ್ಕೋಬೇಕು. Okay, now if in case the distance is this much here, if in case okay T2G ಇದೆ ಅಂದ್ರೆ T2G is very less means what? Central metal atom ಜೊತೆ nearest ಇದೆ ಇದು. That is what? 0.4 delta, 0.04. Sorry, 0.4 delta naught. So ಇಲ್ಲಿ ಯಾವಾಗ Eg ಇರುತ್ತೆ, it depends ಎಲ್ಲಿ ಮೇಲ್ ಬರುತ್ತೆ ತಳ ಬರುತ್ತೆ ಅನ್ನೋದು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾನೆ. Where Eg will come, where T2G will come, how we need to split it up, that also I'll explain. First you have a idea about what is Eg, what is T2G. Okay, so Eg ಏನಾಗುತ್ತೆ 0.6 delta naught. Clear? Delta naught. So this is clear now. What is a delta naught? Delta naught is going to be considered as crystal field splitting energy. So crystal field splitting energy T2G ನಲ್ಲಿ ಇದ್ರೆ ಸ್ವಲ್ಪ ಇರುತ್ತೆ ಮತ್ತೆ Eg ನಲ್ಲಿ ಇದ್ರೆ ಜಾಸ್ತಿ ಫೀಲ್ಡಿಂಗ್ ಇರುತ್ತೆ. Okay, crystal field splitting is more at the topper end compared to the down. Clear? Next, now crystal field theory nalli, in crystal field theory bonding between the metal and the ligand is purely electrostatic. So ಏನೇನ್ ಬಾಂಡ್ ಆಗುತ್ತಲ್ಲ ಮೆಟಲ್ ಮತ್ತೆ ಲಿಗ್ಯಾಂಡ್, that is going to be the purely electrostatic process. Clear? And ligands are considered as a negative point charge, and whatever the ligands we are going to split, that is going to consider as a negative point charge. Clear? Now concentrate properly now how it's been splitted up. Okay, how it's been splitted up. This is the orbital energy. Ide tara ನೀವು actually solve ಮಾಡಬೇಕು in your boards, but this is not for the KCET. It will be there for the boards. They will ask this question, but you need to know this thing to solve the KCET questions also, guys. Okay, it's very important there also. So dxy, dyz and dz square, dx square minus y square and dz square is present. These are all d orbitals of a metal ions when there are no surrounding ligands. Yavaga surrounding ligands illalla avagintadu. Aita? Now these things will be got splitted up here. Okay, they will get splitted up here. Here dx square minus y square and dz square is present, right? These ds square minus y square and dz square is present means what? It is going to be the Eg. Okay, it's going to be the Eg. Now talaga ಏನು ಬರ್ತಿಲ್ಲ ಇದಕ್ಕೆ ಏನಂತಾರೆ T2G ಕರೀತಾರೆ. Okay, these are called as T2G. Yes. Next comes to us the distance and just explain ಮಾಡಿದೆ. So here whatever is the ligand approaching the metal, this orange part which is there at the central metal atom, its ligands are there which are actually approaching the metal. Okay, this is the metal and the ligands are approaching it. So whenever the ligand is approaches the metal ion, there will be a change in the energy of the electrons in the d orbitals of the metal ions, in the d orbitals of the metal ions. Clear? Now how the orbital splitting in the octahedral complex is going to happen? Now this is how the splitting is going to happen. It is a 3D structure of dx square minus y square, and here how it's going to happen? Dz square means what? It is in the EG ನಲ್ಲಿ ಹೇಗಾಗ್ತಿದೆ ಅಲ್ಲ ಅದನ್ನ explanation ಕೊಟ್ಟಿದ್ದಾರೆ. So in octahedral complex the ligands approach along with the XYZ axis and dx square minus y square and dz square orbitals align along the axis. Clear? So the repulsion between the orbitals and ligands leads to increase in the energy. It will lead to increase in the energy. Okay. Okay. Here, so the repulsion between the orbitals and the ligands leads to increase in the energy. Next comes orbital splitting in the tetrahedral complexes. So here also it will be in the form of a T2G at the upper end and EG will be at the down. As we know, in tetrahedral complexes, ligands approaches between the x, y and z axis. So therefore, dxy, dyz and dz square will be the present, has more energy than the dx square minus y square and dz square. So your tetrahedral complex idre T2G ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ EG ತೆಳಗಡೆ ಬರುತ್ತೆ because the energy gap between the T2G and EG is in this way it is going to be mentioned. Clear? In this way it's going to be mentioned. Understood? Understood? Yes. Next comes what? DN system is there. Here the electronic configuration of N minus, that is central metal ion, will depend on two types of energies. One is pairing energy. One is pairing energy. Pairing energy. One more are two conditions in the presence of strong field ligand and in the presence of weak field ligand. We have discussed this already. Okay. We have discussed this already. Fine. One second, guys. Yes, this has how it's going to get splitted. Okay. Now hybridization state and the magnetic nature, how it will be. You people already will know these things, right? Now last comes the factor which are affecting the splitting energy. Factors which are affecting the splitting energy. Okay. So these are the splitting energy affecting the energy, how it's going to be forming. So concept understanding irbeku andrene ivella tiliyodu aita. So delta naught is directly proportional to the charges of the central metal atom and the strength of the ligand is going to depend on what type of a geometry is being given. Depends on that it is going to form. Clear? Examples also there few. Stability of the complex compound has been discussed already. Yes, now comes the crystal field stabilization energy. Crystal field stabilization energy. Now depends now, however it's going to be splitting extra stabilization where the released energy is due to the splitting of the comparison to the no splitting. Okay, like color. DD transition idre color of the complex compound is due to the DD transition. So yavagu color of the complex compound is being found, that time it is going to be according to the DD transition. Okay. Now if in case DD transition is there, then we'll get to know that its visibility is how much? Violet in color. It will be visible to the naked eyes. Okay. It will be visible to the naked eyes. Next, color of the complex compound depends upon the splitting energy. Yes. How much the splitting energy is there depends on that we are going to get it. Okay. Depends on that we are going to get it. Clear? Understood? Yes, color of the F block compounds is due to the FF transition. Again, DD transition itala, adar tarane FF transition. It actually depends on the FF transition also. FF transition also. Clear? Yes, few examples are present. Then the polarization where the color of the same compound can be explained on the basis of the polarization. On the basis of the polarization. So this is the color shown by the metals in the various oxidation state. Okay, +2 iddaga light pink torsutte, and it is the highest if in case it is having a +7. If in case it's having a +7, then that time it is going to show the darkest color. It will show the dark color. Same iron ganite +2 idre, it is going to show the green in color. Swalpa ontara greenish irutte, full greenish iralla, light green irutte. Clear? So ade tara chromium matte cobalt nodkobodu yav tara colors anna form ಮಾಡುತ್ತೆ. Clear? Next comes the structural isomerism also. This also I think we have discussed it. We have discussed it, this thing. Yes, I have given few examples also to solve for you people. Go through those examples also properly, everyone. Okay. So let's see the questions right now, which I have taken it from for you people for the KCET. So let's see how many people are going to answer it. First is, it's possible, yes. So ethylene diamine tetraacetate ion is actually an hexadentate ligand, or it is an ambidentate ligand, or a monodentate ligand, or a bidentate ligand, they have asked. Ethylene diamino tetraacetate. Ethylene diamino tetraacetate. Come on, try it. 10 seconds I will give you. It's very easy, guys. Yav tara madbek annod already helidene. I have already told what type I am going to do it anta. Try it. So what will be the answer? Whether it is going to be the hexa or ambident ligand. Ambident ligand is at least not possible, right? Monodentate ligand not possible, die there. Right, bidentate ligand or hexadentate ligand, that is important now. Okay, yes, the answer will be the hexadentate ligand. The answer will be the hexadentate ligand. Why? So EDTA, which will actually bind through the 6 donor atoms. It's actually donating to the 6 donor atoms. It's actually giving the 6 donor atoms, and C E D T A. Done. So EDTA idre martu bidi and 100% hexane. ಆಯ್ತಾ, ಎಲ್ಲೂ ಕ್ವಶನ್ ಅಲ್ಲಿ KCET ನಲ್ಲಿ ಕೇಳಿದ್ರೆ EDTA ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರೆ 6 ಅಂತ ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಡಿ, ಸಾಕಷ್ಟೇ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಿಚ್ ಆಫ್ ದ ಫಾಲೋವಿಂಗ್ ಇಸ್ ನಾಟ್ ಅನ್ ಅಂಬಿಡೆಂಟ್ ಲಿಗಂಡ್. ಓಕೆ, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋವಿಂಗ್ ಇಸ್ ನಾಟ್ ಅನ್ ಅಂಬಿಡೆಂಟ್ ಲಿಗಂಡ್. ವಿ ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ಡ್ ಆಲ್ಮೋಸ್ಟ್ 20 minutes about the ambident ligand. Come on now, who will try this question? Who will try this question? Yes, C2O4 2 minus, yes, SCN minus, NO2 minus, and CN minus, and CN minus. What will be C2O4 2 minus? C2O4 2 minus. Ambident ligand anta kelidare. Ambident ligands can coordinate through 2 different atoms, but only one at a time. Okay, it's going to coming at the only one at a time. Like examples, CN ತಗೊಂಡ್ರೆ ಅವಾಗ S or N ಇರುತ್ತೆ. NO2 ತಗೊಂಡ್ರೆ N ಮತ್ತೆ O ಇರುತ್ತೆ. Same ಅದೇ ತರ cyanide ತಗೊಂಡ್ರೆ it can bind with the carbon and the nitrogen also. Same ಅದೇ ತರ oxalate ತಗೊಂಡ್ರೆ C2O4 2 minus. So means according to the options which we go, if we go, then bidentate ligands will binding through the 2 equivalent oxygen atoms simultaneously, not through the alternative donor atoms. So because of that only, it's going to act like an ambident ligand. Clear? It's going to act like an ambident ligand. Next, try this. Yes, select an element M whose trihalides cannot be hydrolyzed to produce an ion of the form MH2. Okay, it's MH2O6. I'll write the compound here. MH2O6 3 plus. Okay, they have given the option as Ga, Ln, Ai, B. Try everyone. 10 seconds. I'll give you people 10 seconds. Tell fast. Ga, Ln, Ai, B. So the answer will be B, that is boron, because group 13 trihalides hydrolysis in the water. I have told you. So yav group 13 nalli iruttalla, ಸಾರಿ ಗ್ರೂಪ್ ಸ್ಪೆಲ್ಲಿಂಗ್ ರಾಂಗ್ ಬಟ್ ಸೊ ಗ್ರೂಪ್ 13 ಅಲ್ಲಿ ಯಾವ್ಯಾವ ಇರುತ್ತಲ್ಲ ದೇ ವಿಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಹೈಡ್ರೋಲೈಸ್ ಇನ್ ದ H2O. It will be completely hydrolyzed into the H2O. So we can give simple examples also for them. Okay. Now boron is actually lacking behind the d orbitals and its trihalides hydrolyze. Okay. Lagging behind adre hydrolyze ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ because hydrogen will go and bond there. ಈಸಿಲಿ ಇಟ್ ವಿಲ್ ಗೋ ಇನ್ ಬಾಂಡ್. ನನಗೇನು ಬಾಂಡಿಂಗ್ ಆಲ್ರೆಡಿ ಯಾರೋ ಒಬ್ರು ಬರ್ತಿದಾರಪ್ಪ ಬಾಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಮತ್ತು ನಾನೇ ಗಪ್ಕೊನ್ಬೇಕು, ನಾನು ಹೋಗಿ ಬಾಂಡ್ ಆಗ್ತೇನಲ್ಲ. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ವಾಟರ್ ಇಸ್ ಡೂಯಿಂಗ್ ಆಕ್ಚುಲಿ. ದಟ್ ಇಸ್ ನಾಟ್ ದ ಎನಿ ಇಶ್ಯೂ ವಿತ್ ದ ಹೈಡ್ರೋಜನ್. ಇಟ್ಸ್ ಡೂಯಿಂಗ್ ಇಟ್ಸ್ ವರ್ಕ್. ಓಕೆ, ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಆನ್ಸರ್ ವಿಲ್ ಬಿ ವಾಟ್? ಆಪ್ಷನ್ ಡಿ, ದಟ್ ಇಸ್ ಬೋರಾನ್. ಕ್ಲಿಯರ್? ಡನ್. ನೆಕ್ಸ್ಟ್. Which of the following forms the set of the complex and double salt respectively? This is very easy. Okay, very easy and a direct question it is. Okay, direct question. Yes Kirtana, very good. Try this question everyone. Idan try ಮಾಡಿ. Yes, so option C will be the correct answer. K2P2Cl2 and 2NH3 and KAI, that is aluminium, SO4 2 12H2O. So here what happens actually is, so whatever the complex reactions are happening, those will get retained into the complex ion. So in a solution, for example, like it will be having already the contents of the PT, amine complex compounds will be present there. So it's already present, then typical of that coordination compound will start becoming, means convert into the double salts itself. It will start converting into the double salts itself. So other choices of the pair hydrates or salts that are not recognized has the complex plus. Okay, ಏನು ಉಳಿದಿದ್ದೇನಿದೆ ಅಲ್ಲ, this all are not complex plus. Okay, those all are going to not be the complex. Only this option C will be the complex plus. Clear? Clear? Okay. Okay, so these are the questions. I have given still more 2-3 questions. You can go through those questions also. So and even we have discussed of a few points also ಕೊಟ್ಟಿದ್ದೇನೆ last ನಲ್ಲಿ. One second, I'll show you people. Yes. Geometrical isomerism in the square planar complexes ಬಗ್ಗೆನೂ ಸ್ವಲ್ಪ ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೇನೆ ನಿಮಗೆ, so that it will be easy for you people to study. ನಾನು ಏನು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟೆ ನಿಮಗೆ, ಏನೇನು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟೆ ನಿಮಗೆ ನಾನು. ಸೊ ಇಟ್ಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಯು ನೀಡ್ ಟು ಡೂ ಇಟ್ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ದ ಫ್ಲೋ ಚಾರ್ಟ್. KCET ನಲ್ಲಿ ಫ್ಲೋ ಚಾರ್ಟ್ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ ಅದು ಮೇನ್ ಟಾಪಿಕ್ ಇಸ್ ವಾಚಿಂಗ್ ಯು ಫಾರ್ ದ ಫಸ್ಟ್ ಟೈಮ್. ದರ್ಶಿನಿ, ಓ ಹಾಯ್ ದರ್ಶಿನಿ, ಹಾಯ್. ಸೊ KCET ನಲ್ಲಿ ಮೇನ್ ಥಿಂಗ್ ಅಂದರೆ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗಿ, ಸ್ಪೆಷಲಿ ಇನ್ ದ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್. ಬಿಕಾಸ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ನಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಜಾಸ್ತಿ ಇದಾವೆ, ಲೈಕ್ BBT ಇಸ್ ದೇರ್, CFT ಇಸ್ ದೇರ್, CMA ಇಸ್ ದೇರ್, ಸೋ ಮೆನಿ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಆರ್ ದೇರ್. ಆಲ್ ವಿಲ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಯಾವ್ದು ಫಸ್ಟ್ ಮಾಡಬೇಕು, ಯಾವ್ದು ಬಿಡಬೇಕು ಅನ್ನೋದು ಯಾರಿಗೂ ತಿಳಿಯಲ್ಲ, ಭಾಳ ಮಂದಿಗೆ ತಿಳಿಯಲ್ಲ. ಫಾರ್ ದ್ಯಾಟ್ ಪರ್ಪಸ್ ಓನ್ಲಿ, ಒನ್ ಸೆಕೆಂಡ್ ಗೈಸ್. So for that purpose only you need to make a flow charts. Okay, ಎಷ್ಟು ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಮಾಡ್ತಾರಲ್ಲ ಅಷ್ಟು ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಈಸಿ ಆಗುತ್ತೆ, ಮತ್ತೆ ನಿಮಗೆ ನೆನಪುಳಿಯುತ್ತೆ. ಓಕೆ, ಇಷ್ಟೆಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದಾವೆ, ಇವನ್ನೆಲ್ಲ ನಾನು ಸ್ಕಿಪ್ ಮಾಡಬಾರ್ದು. ಬಿಕಾಸ್ ಒಂದ್ ಯಾವ್ದಾದ್ರು ಸ್ಕಿಪ್ ಮಾಡಿದ್ರೆ, ಒಂದ್ ಯಾವ್ದಾದ್ರು ಟೈಪ್ ಸ್ಕಿಪ್ ಮಾಡಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ನಿಮಗೆ ತಿಳಿಯಲ್ಲ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ನಿಮಗೆ ತಿಳಿಯಲ್ಲ. ಫಾರ್ ದ್ಯಾಟ್ ಪರ್ಪಸ್ ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಯು, ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ನೋ ದ concept and its flow chart very well, especially in this chapter. Okay, especially in this chapter. ಅದರ ಸಲುವಾಗಿ ನಿಮಗೆ ಒಂದು ಸ್ಪೆಷಲಿ ಲೈವ್ ಕ್ಲಾಸ್ ನಲ್ಲಿ ನಿಮಗೆ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡಿ ತೋರಿಸಿದೆ ನಾನು. ಓಕೆ, ಐ ಹ್ಯಾವ್ ಡನ್ ದ ಫ್ಲೋ ಚಾರ್ಟ್ ಅಂಡ್ ಶೋನ್ ಯು ಪೀಪಲ್ so that you people will understand it. Okay, yes. ಸೊ ಈ ಥರ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡಿ ನಿಮಗೆ ತೋರಿಸಿದ್ದೆ ನಾನು. ಯಾಕೆ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡಿ ತೋರಿಸಿದೆ? ಸೊ ದ್ಯಾಟ್ ನಿಮಗೆ ಈ ಥರ ಒಂದು ಐಡಿಯಾ ಗೊತ್ತಾಗಲಿ ಹೇಗಂತ. ನಾನು ಜಸ್ಟ್ ಹೆಡ್ಡಿಂಗ್ಸ್ ಅಷ್ಟೇ ಬರೆದಿದ್ದೇನೆ, ಬಟ್ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಇವನ್ ರೈಟ್ ದ ಡೆಫಿನೇಷನ್ಸ್ ಆಫ್ ದೆಮ್. ಓಕೆ, ಇದಕ್ಕಂದ್ರೆ ಏನು ಡೆಫಿನೇಷನ್ ಅಪ್ಪ ಅದನ್ನೂ ಬರ್ಕೋಬಹುದು, ಇದಂದ್ರೆ ಏನು ಡೆಫಿನೇಷನು ಅದನ್ನೂ ಬರ್ಕೋಬಹುದು. ಈ ಥರ ಡೆಫಿನೇಷನ್ಸ್ ಬರ್ಕೊಂತ ಹೋದ್ರೆ, ಈಗ ನೀವು ಯಾವ್ದಾದ್ರು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ ಇದು PYQ ಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೀರಾ KCET ಇದು, ಆಯ್ತಾ? ಸೊ ಅದು ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕೆ ಮುಂದು ಇವನ್ನೆಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಒಂದ್ಸಲ ರಿವೈಸ್ ಮಾಡ್ಕೋಬಹುದು. ರಿವೈಸ್ ಮಾಡಿದ ತಕ್ಷಣ ಡೈರೆಕ್ಟ್ಲಿ ಹೋಗಿ PYQs ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ರೈಟ್? ಈಸಿನೋ? ಈಸಿ ಆಗುತ್ತೆ ನಿಲ್ಲೋ? So I'm telling you, this chapter is actually having a high weightage. High weightage ಇದೆ. ಮತ್ತೆ ಈ ಚಾಪ್ಟರ್ ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ ವಾಟ್ ಯು ನೋ, ದಿಸ್ ಇಸ್ ದ ಈಸಿಯೆಸ್ಟ್ ಚಾಪ್ಟರ್ ಆಕ್ಚುಲಿ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ನಲ್ಲಿ. ಸೊ ಅದಕ್ಕೆ ಈಸಿ ಯಾವಾಗ ಆಗುತ್ತೆ, ಯಾವಾಗ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋತೀರ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ. ಸೊ ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಯು, ಡೋಂಟ್ waste your time, utilize to understand the concepts and try to solve more and more PYQs. So today I have done fully I have focused with the theory itself more than the PYQs which we need to actually solve, but I have focused more on the theory itself. Why? Because in this chapter theory is very very important guys. In the PU board concept, in the NEET perspective, in the KCET perspective, this theory is very important because ಎಲ್ಲ twisted questions ಕೇಳಿದ್ರೆ ನೀವು theory perfect ಇದ್ರೆ immediate ಆಗಿ ಆನ್ಸರ್ ಮಾಡಬಹುದು, ಮತ್ತೆ immediate ಆಗಿ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ ಅಂತ ಆಕ್ಚುಲಿ ಕ್ವಶನ್ ಕೇಳಿದಾರ ಅನ್ನೋದು. ಆಯ್ತಾ? So till then, see you everyone. Next class is Baswaraj Sir's, so he will be continuing the next class now. Till then, see you in the, I think Wednesday I will be taking the class, next class. So see you in the Wednesday's class. So if you have not marked your attendance, mark your attendance. I want to hit, everyone needs to like the button and subscribe to the channel. Share it with your friends so that they will also have a free content, because we are giving the free content. Then don't forget to subscribe to it. Till then, see you. Bye bye.